Appreciate you being here today as we explore a deployable aerial communications architecture, or DOCA as we've called it. This is something that certainly I think has been brewing in Richard Lee's mind for some amount of time, but it came to the fore as we considered the effects of Hurricane Katrina when absolutely all of the communications architecture was impacted. And again, as we considered the national level exercise this past year, where we were looking at a significant exercise of the New Madrid Fault, where several states' communications infrastructure could have been impacted severely. So I think you're going to be very impressed with the panels that are lined up today, the discussion that we're going to have, and I appreciate you being here to participate in it, as well as those people who are participating with us on the web. I'm pleased to introduce Glenn Cannon, our keynote speaker. Glenn is the director of the Pennsylvania Emergency Management Agency, or PEMA. He comes to that from serving as an advisor to many on disaster preparedness, on defense, and many other things like that, as well as being a former assistant administrator at FEMA, where he did direct disaster operations. And so thank you very much. And if I could, Glenn, if I could ask you up, and if you would help me welcome Glenn Cannon.
Thank you, Admiral.
Thanks for being here. Appreciate it.
Thank you very much. Good morning, everyone. It's nice to be here in the sun. I just spent the weekend in having a Halloween blizzard in Pennsylvania. That was an unusual event, one that we didn't expect. But it again illustrates the point. I've been doing emergency services and public safety for a very long time, and one of the basic tenets that I always tell my folks is that communications are the backbone of emergency response. And when communications fail, our mission can fail. And when public safety's mission fails, people can die. And so that becomes the baseline that I have always operated from as it relates to emergency communications. We know that a lack of communications can affect reaction time, it affects command and control, and it affects organizational efficiency. Reliable and robust public safety communications is essential during all phases of emergency, in particular response and recovery. We have a history of looking at communication outages for public safety that has been very well documented during Hurricane Andrew or Hugo or Katrina, or certainly September 11th, the West Coast earthquakes, the East Coast blackouts. And not too long ago, we had a little shake, a little earthquake shake that for 45 minutes, all the cell phones in our part of the country went off the air. You couldn't get a signal. So we need to have multiple options and solutions available in our toolbox that we can use when bad things happen to remedy the loss of public safety telecommunications as soon as possible. And that toolbox includes lots of things. You know, it includes amateur radio and CB and advanced communications like satellites and COWS, cells on wheels, as well as what we're here to discuss today. Geography, demographics, existing system design and operations, type of disaster, existing conditions, availability of resources, communication infrastructure status, utilities, radio equipment type spectrums, and who needs to talk to whom, all play into which communication solution we're going to use to try to reestablish communications during a disaster emergency operation. Communications are essential, again, to the success of our mission. Recently, we had Hurricane Irene in our state, and we had Tropical Storm Lee, and in some places it knocked power out for 6 to 8 days, power that supported the telecommunication system as well as the 911 PSAPs. Electrical power loss to tower sites and telco switches and their offices is the most common cause of public safety communication system failure, followed by tower and equipment damage from the actual event. When public safety radio networks go offline during a disaster, the speed in which reestablishment of those communications happens will directly affect the lives, the suffering, the security, the property, and the environmental damage that we're out there trying to prevent. Repair time is based on the amount of damage to that infrastructure, availability of materials, equipment, qualified service personnel, access, and the status of the event. Is it still ongoing, or is it behind us? Has most of the damage already occurred, or are we in the process of it? 21st, public safety communications require immediate access and superior voice. They require up and down broadband data transfer and high-speed streaming video. The aerial solution is based on proven military experience. There is a true need to civilianize more military technology to meet the demands of modern public safety response. This solution provides a quick temporary solution in both urban and rural environments. It can provide an extra dimension to the incident commander with real-time video on top of the reestablishment of basic and advanced communication linkages. It can also enhance scene safety. It can reestablish talk-in and talk-out capability. It can expand the capacity of trunking systems. Eyes in the sky. It affects us in hazmat situations, SWAT situations, special event situations, disaster recon, and criminal surveillance. So as we strive to protect the lives and safety of the people of our country, I believe that the program we're going to learn about today is, again, one more tool in our toolbox that lets us do our job. If we're going to save lives, one of the things that I've heard Director Fugate say is we go big and we go fast. And we have to go with enough resources to overcome whatever the threat is that we're dealing with at that moment in time. And communications is essential to us being able to do that job. If we don't get there fast and quick, then our rescue mission turns into a body recovery mission. So this is critically important as another tool, and I thank you for the chance to address you today. Thank you.
Glenn, thank you so much. I appreciate this. And I'd now like to turn it over to Rich Lee, our first in the first panel. Richard Lee is our Associate Bureau Chief for the Public Safety and Homeland Security Bureau, and is concentrated really for a large part of his career here on emergency communications, on emergency support function number 2, and making sure that we have a good, tight relationship with FEMA and our other federal partners. Rich also was a team leader, took a team down to Haiti following the January 12th, 2010 earthquake. And so he actually has on-the-ground experience from that and other disasters where he's actually been on the ground with disasters. So at this point, if I could turn it over to Richard Lee.
Thank you, Admiral. Good morning, everyone. As you've heard from my boss, Admiral Barnett, and from Director Cannon, an entire region can be affected by a catastrophic event. And it engages thousands of responders and stakeholders with diverse skills, resources, and fields of expertise. The ability of these individuals to communicate internally and externally is critical to saving lives, protecting property, and maintaining the rule of law. So I believe if a DECA system were available today, users on the ground could continue to rely on their day-to-day communications devices in a transparent manner. And I'm honored today to moderate the first panel and to have such a distinguished panel of experts to discuss the benefits of developing a DECA system. But in the interest of time and to allow for questions at the end, I'll not read their bios, but you can find their bios listed in your program. And I'll introduce each one just before their presentation. I believe there is a time limit on presentations, and we have a timekeeper here. And she'll push the button, and I don't know if you'll hear noise or something, but there is a time limit. Our first panelist is Tex Boyer. Tex is the Chief of Emergency Communications, and he is the Regional Emergency Communications Coordinator for FEMA Region 4. And I've worked with Tex starting with Gustav, Hannah, Irene, and we have a very good and close relationship, and I'm happy that Tex is here today. So Tex, you can start. You can sit and do it here.
Yeah, okay. Morning, everybody. I am Tex Boyer. As Rich said, I'm the Regional Emergency Comm Coordinator. Used to work for Glenn Cannon, as a matter of fact, on the first team when he was over at FEMA. This morning, I'm going to speak to you about some successes that we've had in the past using airborne communications platforms, specifically repeaters, mounted in Civil Air Patrol aircraft. And why did we go with CAP aircraft? Well, we did that because it's relatively inexpensive. We only have to pay for the fuel. The pilots are volunteers, and of course, with fuel being paid, the pilots will fly just about as long as you can keep gas in the airplane. In any case, we have found in the past that when the infrastructure below is damaged and you can't move vehicles around, such as cows and other kinds of vehicles, or in the instance we had in Kentucky where everything froze, power went off, and there were no communications infrastructure really available, we had to have some way to be able to set up repeaters so that handheld radios, as an example, could be used by the National Guard when they went door to door searching to see whether we had survivors. People were in what amounts to a deep freeze with no way to get heat or water, that sort of thing, for several days in Kentucky. This was in 2009. I'm not going to read the slides to you. You can do that yourself, but this communications white paper that I've read, the DACA white paper, talks about the whole community initiative that Mr. Fugate has started. Actually, it is pulling together some initiatives that we at FEMA have been operating under for several years. In fact, our aerial platform communications studies and the deployment of those communications equipment has been going on since the mid-1990s. The approach I show you here, that's a smaller of the Civil Air Patrol aircraft, but we use a single engine fixed wing for high to medium altitude orbits. We've got tactical repeater packages, and we have both broadband and multi-frequency antennas installed on the aircraft. This is a volunteer agency, as I said, and the cost is very, very reasonable. In 1998, we used the Civil Air Patrol aircraft, the Florida Wing lifted Forest Service repeaters, and set up racetrack orbits in the air so that the firefighters could communicate with one another. Not coincidentally, by the way, Mr. Fugate was in charge of disaster communications for the state of Florida during this period of time. In 2009, this is a slide on the Kentucky ice storm that I mentioned to you. The National Guard needed to go door to door and check to see if we had survivors in the homes, or this would have turned into a body recovery mission, as Mr. Cannon mentioned earlier. We also didn't want to have our National Guardsmen out there in this kind of a situation without some way to get help if that help needed to be brought to them, if they were injured, that sort of thing. By the way, the Civil Air Patrol aircraft flew dawn to dusk flight operations during this particular mission. During the Virginia earthquake that I heard mentioned earlier, the Virginia Wing, flew tactical repeaters to provide real-time emergency communications for units in the state of Virginia. The 2011 Texas wildfires, this is one where I have a cost just to give you an example of what the cost was. The total cost for 388 man days, or I think that's 65 sorties, 120 air hours, was a little over $10,000. So you can see that's very, very reasonable cost. Right now, FEMA and the USNR task forces are working on an agreement with the Civil Air Patrol so that they can get their repeaters and antennas mounted in the aircraft for the Texas Wing. Briefly, lessons learned. One of the things that we found in making this a successful deployable package is to make sure that we prepare for it in advance. Of course, that's sometimes difficult trying to come up with the money to put an unproven project online, but we've been able to do that. We also have to test system operations, and of course that means we have to come up with fuel money to run those tests. Since CAP is so efficient, it really costs very little money for us to run these tests. But it's still one of those things that it's difficult to try to sell executive management on trying to fund these kinds of tests. Another one of the approaches that we've taken to try to speed up the deployment of these packages is pre-scripted mission assignments, in which we agree with various agencies, and in this case the Civil Air Patrol, to pay for the expenses, and in this case again it's fuel, and also in some cases we have to pay for some of the connectors and that sort of thing in order to be able to get the repeaters mounted in the aircraft. And that's all done in advance, so that when a disaster happens we don't have to fumble around and try to figure out whether we can get papers signed and agreements done, that sort of thing. And these have to be established prior to the event. I'm not going to get into very much of the technicals here. I do show you up there that we have mounted VHF, UHF, and 700-800 megahertz antennas on aircraft. We have some permanent installations. We also have some temporary installations in which we actually, believe it or not, hang the antennas outside the window of the aircraft. The power ports for some of the older Civil Air Patrol aircraft, that turned out to be a little bit of a problem. We had to replace those power connectors in order to be able to put the repeaters into the aircraft and make them operate successfully. The new Cessnas, Civil Air Patrol ordered them with these standardized connectors for supplying power to the repeaters, and so that's worked out very well. Just so you know, there are 508 aircraft that CAP owns in CONUS aircraft locations. Part of that has been funded by the CAP Corporation, and the other part has been funded by the United States Air Force, since CAP is the Air Force's auxiliary. We also have aircraft in Alaska, Hawaii, and down in Puerto Rico. Just in summary, to let you know, we in FEMA, across the country, as a matter of fact, have used airborne communications assets in support of disaster operations quite successfully in the past. We've worked through a lot of the problems, so I'm looking forward to working with the engineers here at the FCC to develop this architecture and make this a real success as we broaden this out and make it a standard. Thank you very much.
Thank you, Tex. You're right on time. Tex, as you know, and you've utilized one of our other capabilities we call roll call, which is a ground-based sensing capability to identify surviving stations, including broadcasts and land mobile radio. I think in our discussions you were interested in seeing if that could be turned into some type of aerial capability.
Well, yes, and as a matter of fact, one of the problems that we see, for instance, if we have an Madrid seismic event, if the roadways and bridges are damaged and you can't move roll call on the ground around to be able to pick up the after effects of the earthquake, roll call is not going to do us a great deal of good. However, if we can get it installed on an aircraft and we can fly it over the area, so that we don't have to worry about the ground infrastructure, then I think roll call will go a long way towards being much more useful for us.
All right. Thank you for your comment. Our next panelist is Captain James Cash. He is Chief of C4 IT and Sensor Capability at the U.S. Coast Guard. And let's see if I can mumble out what C4 is. Is it Command, Control, Communications, Coordination, and IT? Computers and IT. Okay. Captain Cash and I met doing numerous conference calls during the Gulf oil cleanup process, where we had to coordinate the use of spectrum with state, locals, with industry, and it was a big job, but we were able to get it done. So Captain Cash, I give you the floor.
Well, thank you, Richard, and thanks for the opportunity for being here today. I represent first responders within DHS, and as a first responder, one of our challenges is to look at some of the new technologies that are coming out and how it can better provide mission effectiveness, and is it suitable to be able to put into the hands of first responders during incidents, whether it's a post-disaster event like a Hurricane Katrina, or during an event like the Deepwater Horizon, where all of a sudden you have 40,000 responders, 6,000 vessels of opportunity, and hundreds of people coming in to do command and control over an incident of that magnitude, working not only within federal, state, local, tribal organizations, but also bringing in our our contractor support, as well as the many volunteers who wanted to participate in that historic event. The one problem in the trying to work first responders into adopting these new mobile technologies is the third area that acquisition is concerned with. First, we're concerned with effectiveness, suitability. The final piece is survivability. For these new mobile IP devices to be able to turn humans into sensors, to be able to give them the ability to have voice, video, and data in their hands, first responders must be convinced that we have a survivable network. Today, that really has been traditionally from the use of cows bringing in capability to restore the terrestrial network. But in times of natural disasters like hurricanes, it's often difficult to bring land vehicles into position to be able to restore these networks. So the concept of an aerial restoration capability is very intriguing, both for the restoration of the network, but really to assure first responders that this network that they are going to be relying on every day will be there to support their mission needs. The President has a wireless initiative to be able to provide voice, video, and data, and it's called the Interoperable Wireless Network for Public Safety, where survivability, I believe, is the key. The Office of Emergency Communications has a committee called the One DHS Committee, where we are putting together a strategy to be able to move our first responders to these mobile devices. The Coast Guard, we have many land solutions. Our Rescue 21 system, our VHF, to communicate with the public, the mariners, as well as our UHF capability for our command and control and tactical communications, is in place, and it rides on an IP network, DHS OneNet, and we are moving now to back it up with VSATs. That is proved to be very reliable recently with Hurricane Irene. We have a few VSATs on our towers along the East Coast, but we're looking to expand. However, some of those devices do go down and they don't survive the storm. So how do you restore it quickly? And I think that really is this aerial concept helps to move us in the right direction. Our ConOps for first responders, again, is voice, video, and data. In Deepwater Horizon, our challenges were command and control, information management, and remote sensing. Under command and control, we had the need to be able to track all of those responders. I talked about the 40,000 people, the 6,000 vessels that were operating near shore. We needed Blue Force tracking in those incidents. And in one case, we were looking at establishing a Blue Force tracking for the vessels using our VHF system called the Automated Identification System, our tracking systems for vessels at sea. When we looked at installing that capability on board those 6,000 vessels in small areas, in very tight areas, we quickly did some calculations and were worried that we were going to produce a denial of service attack on ourselves, that our receivers that were in our fixed terrestrial networks would have been overloaded. So in the aerial networks, as we continue to look forward, the potential may be for increasing capacity in an area where we need it, where there is an incident. And that's an area that I think first responders are concerned with as well, the increase in traffic that our infrastructure, land-based infrastructure, may not be able to handle. But also the need to be able to push our geospatial information out to responders. Whether in our case during the Deepwater Horizon incident was men and women who were out finding tar balls on the beach, and as they collected those tar balls, or those tar balls were reported by the citizens using social media, how did we get that information to those teams who were out trying to do restoration and recovery following that incident? Those are the types of things that we're looking at, leveraging these new mobile devices to be able to push those pictures that you can do today. And I'm sure many of you are doing with your personal and potentially organization delivered mobile devices. But those, be able to track people, to be able to put it on a map, and to be able to pass command and control information, both visually, but also voice. One of the challenges in these major incidents are that we rely on our voice radio systems, this good old 1940s technology that works very well. But to be able to pass that quantity of data to all of these responders, and responders who need to communicate to commercial entities, federal entities, state entities. What we ended up doing to accomplish that in Deepwater Horizon was hand out radios that worked with BP or the state of Louisiana or the federal government. And very soon, these folks started to walk around and they looked like a walking communication station. We need to change that model. Mobile IP devices allow us to have interoperable communications and command and control. We can put those devices into talk group, and demonstrations today already prove that we can connect that mobile device into a land mobile radio system and allow people to communicate. That is really the power of our information technology that is growing in industry and the federal government needs to adopt. Information management, the collection of all of the results of the efforts of all of the responders on scene. We collect those in ICS forms. Today we need to be moving those to mobile applications so that we can collect that, feed it up through the organizations to provide the information to our commanders so that we can move resources to the areas that are most needed. And also to inform not only our leadership in the federal government and the state governments, but also the American people of what we're doing to support them during these times of disaster. Finally, we need to move video. I think as Tex mentioned, being able to use our aerial platforms. Deepwater Horizon, we had over 160 aerial platforms that were flying, but very few of those could actually move their imagery to the commander in near real time. We're investigating the use of camcorders with cellular devices on them so that we can get that information that they see to the commanders so that we can respond to these incidents effectively. And finally, air-to-ground coordination is critical. We need to be able to get aircraft to be able to speak to responders on the ground. One example with the Coast Guard in Deepwater Horizon incident are aircraft, whether they're Civil Air Patrol, the United States Coast Guard's auxiliary, who fly airplanes as well. They usually have VHF AM radios. Our responders in the maritime community, FM. Interoperability, IP really holds some promise. So the network allows us to be mission effectiveness. Survivability is the key. We're very interested in continuing to support Richard and the FCC in the work in DACA. Thank you very much.
All right. Thank you very much, Captain Cash. I do want to thank you for your service to our country. And also, people probably don't know, unless they're boaters, that every day the Coast Guard is out there helping boaters who are in trouble, saving lives. And so we thank you for that. Our next panelist is Brian Steckler. Brian is the director of Hastily Formed Networks at the Naval Postgraduate School. I met Brian 2 summers ago at MIT during a DARPA-supported workshop on developing strategies that could expand communications during widespread disasters. So Brian, I give you the floor.
Thank you. Thank you, Admiral, for letting me be here today. Let's see if I get these slides up. So hastily formed networks. How many here is that a new term for in the room? More than half. So I'll quickly define that. And then I'll, since I'm a retired naval officer, I'll give a couple of sea stories of deploying wireless networks in major disasters in Hurricane Katrina and in Haiti to give an idea of some of the challenges that we have going forward with something like DACA. And then a couple other examples of how we use some of our other military assets in disasters. I use this 9-piece puzzle to kind of put all of the pieces together that are needed to deploy a rapidly deployed communications network or a hastily formed network on purpose in the center.
Brian, if I could just interrupt just for a second, please.
Brian, I apologize. We wouldn't do this except for we've been waiting on the chairman, and we're very pleased that Chairman G.S. Janikowski is with us today from his first day at the commission when he told the Public Safety and Homeland Security Bureau to do a 30-day review of the FCC's ability to respond to emergencies. He's placed an emphasis on emergency preparedness and emergency communications. Mr. Chairman, thank you so much for spending time with us this morning and this great group of first responders and experts who are examining the deployable aerial communications architecture. Thanks, sir.
Thank you, everyone, and good morning. Like many other people who I suspect are running late, I ran into Washington's traffic situation this morning. But all of you, thank you for being part of this FCC workshop on deployable aerial communications architecture, and happy Halloween. Admiral Barnett, always in a great costume today as Atticus Finch, for those of you who didn't know that. But I do want to thank Admiral Barnett and all of our staff and our Public Safety Bureau who are doing an outstanding job every day focusing on what really is a very broad range of issues to make sure that we're harnessing every opportunity around new communications technology to provide for the public safety of the American people. We've had a busy couple of years, as you know, and working on many different things. We've initiated a proceeding to ensure that the public has access to broadband technologies to communicate with 911 dispatchers and to accelerate the deployment of next-gen 911. It is still an amazing thing that people can't text 911 if you snap a photo with your smartphone. You can't just send it to 911. Same thing if it's a video. We've helped establish a framework for an interoperable public safety network for public safety personnel, including adopting a common air interface for such a network. The public safety broadband network is so important. It's important that Congress move forward on funding it. In the meantime, we've done everything we can to develop these common standards, to move forward with waivers, to put us in a position where our first responders can have this important part of the communications technology landscape. As many of you know, we've launched what we call PLAN, which will give federal, state, and local government officials the ability to send alerts in times of emergency to your mobile devices, a prioritized alert that will help you know where to go, what to do in the event of a real disaster. This is an example of areas where our engagement with other countries helps us identify opportunities and move forward on them. And in fact, the fact that Japan had a similar alerting system in place helped save lives during the very terrible earthquake and tsunami that they had recently. More recently, in fact, just last month, our Public Safety Bureau released a white paper on the role of deployable aerial communications architecture in emergency communications, in which today's forum was recommended. As you know, communications capabilities may be limited during and immediately after a disaster when the terrestrial communications infrastructure can get damaged, become unavailable for a period of time. As all of us rely so much on communications, our public safety networks, and the ordinary business of life, this can complicate even the most prepared response effort. In the first 12 to 18 hours after a catastrophic event, deployable aerial communications architecture has the ability to temporarily restore critical communications, including emergency communications and 911 calling. For example, deployable architecture would have been useful in situations such as Hurricane Katrina, when 38 911 call centers became inoperable and over 3 million customers lost telephone service. Implementing deployable aerial communications architecture would ensure the restoration of such emergency communication services during similar disasters. These kinds of capabilities are not science fiction. They're already being used by the U.S. military for localized communications and to provide enhanced coverage areas. So today I'm pleased we'll hear from a distinguished group of experts, including our military partners, to explore the benefits of the use of deployable architecture during emergencies and the different technologies available. This workshop will also explore the issues associated with the use of deployable aerial communications architecture, including how to protect terrestrial uses from harmful interference as they're restored, how best to coordinate such use, and the most efficient method to authorize such uses during an emergency. These are all critical issues to explore, and to this end, the workshop today is just the first step in our consideration of deployable aerial communications architecture. We plan by the end of the year to consider the initiation of a proceeding at the FCC, beginning with a notice of inquiry to delve even deeper into these important issues. I want to thank everyone involved for participating in this. I'm thrilled that this is happening. There's so much of our communications ordinary uses today that would have seemed like science fiction just a few years ago, even this iPad or the iPhones or other devices. And yet they're all here. Ordinary consumers every day are making advanced communications part of their lives. It doesn't make sense for public safety to be behind, and to have these kinds of efforts to explore in a serious way ideas that we know from a technology perspective have the ability to work and save lives in the event of emergencies and disasters. It's very, very important. And so I appreciate all of you being here today to participate in this. Admiral Barnett, again, thank you very much. I'll be getting a detailed briefing on what happens here today, and I do hope we can continue to engage with all of our partners to make progress on this and other vital public safety communications issues. Thank you very much.
Yeah, so that Halloween hex on traffic is something that visits us on other days other than just October 31st. But so, Brian, thank you for allowing that interruption. I'll turn it back over to you and to Richard.
And he gets a reset of the timer. So.
My lucky day, Halloween. See if I can get that slide back up. So I'm representing a rapidly deployed communications network by these 9 pieces of this puzzle here. And I'm not sure how well you all can see that, but in the very center of that puzzle on purpose is access to the satellites. Broadband access to the internet via VSAT or BGAN is the key. If in a disaster all forms of communications are out, that's our least common denominator. That gets us our voice and our data. I won't bother going through all the other pieces of that puzzle there, except to say that the 2 others in the center there, Wi-Fi and WiMAX, are the key technologies along with VSAT to be able to get people on the ground communicating within minutes after a mega disaster. A few of the activities that we've had at the Naval Postgraduate School, taking faculty and students and vendors and contractor research partners with us, is the tsunami in Southeast Asia back in December 2004, Hurricane Katrina here in the U.S., of course, a year later. We've been on the 2 U.S. hospital ships, the Comfort and the Mercy, doing humanitarian missions and also disaster relief missions, and then the earthquake in Haiti last year. First of all, Hurricane Katrina was where we really cut our teeth deploying these wireless technologies. Y'all might recall the center or the eye of the storm went through Harrison County, Mississippi. We were right next door in Hancock County, Mississippi, deployed to get the Naval Oceanography Center at Stennis Space Station back up because they were completely offline, and they did the weather services for our military and our allies. No one could communicate with them from the outside world. They were completely cut off. So we were sent in to find out what was wrong. We got in there, found out that they were just coming back online, that the community had brought in big satellite terminals and they were starting to get broadband connectivity. So our bosses sent us over to find the local emergency operations center, which was set up at an elementary school, and the EOC director said, go find the Hancock County Hospital. They are offline, and FEMA and the DMAT and the DMORT and ambulance services and everyone else is deploying there, and we cannot talk to them. They're cold and dark. So we drove over literally looking for them. Roads were in pretty bad shape, found them, deployed a network starting within 4 hours of getting our equipment on the ground, dealing with this list of problems. And I've heard these problems alluded to with our previous speakers there. When there's no power, there's no copper, no fiber, data infrastructure, there's no UHF, VHF push-to-talk radio for the early responders to be able to do their voice communications. Cellular service normally gets jammed very quickly and stays jammed for quite a while. Satellite phones even become overwhelmed. broadband satellite service becomes overwhelmed, and then not enough satellite or other communications equipment can get into the disaster zone. So you were facing all of those problems. So going back to that puzzle, those first three, the middle three aspects of that puzzle, Wi-Fi, WiMAX, and meshed, Wi-Fi, WiMAX, and meshed VSAT, allow you to get on the internet to do voice and data communications quite quickly. Will an airborne wireless delivery option augment an on-the-ground delivery of wireless communications? I think it will. This is a representation on Google Earth of what we did set up in Mississippi in Hurricane Katrina. The red line is a satellite connection out. The green circle is that hospital with a meshed Wi-Fi infrastructure, meshed cloud. Then we jump a WiMAX link from the hospital to a Bay St. Louis and Waveland Police and Fire Department, set up another Wi-Fi cloud, take another WiMAX hop to an elementary school that was a Red Cross shelter. We did this over the course of several days with Hurricane Rita bearing down on us. So this was people on the ground deploying antennas on tops of buildings with duct tape, literally, finding whatever we could to deploy these networks. Very labor intensive in a semi-unsafe environment. We were hearing gunshots in the background, not as bad as in New Orleans, but we were hearing, bad guys out there and trying to deploy these things, and in some cases leaving the technologies alone and unguarded and knowing that it could get stolen. Somebody would want to take a radio or a solar panel, so we had to worry about that constantly. Then we continued to expand that network, and we kept the network running for about 6 weeks, and then transitioned to the private sector and the local government to run that network. A lot of lessons learned there, particularly the effects of no comment situational awareness, that voice over IP technologies were extremely beneficial. The early responder community really needed their voice communications. Also, and I heard the captain talking about this earlier, pre-positioning assets and contracts before disaster happens is critical. Communications and otherwise, food, water, shelter, health, medicine, communications, power, fuel, everything needs to happen ahead of time. Our 2 hospital ships, those of you that don't know, the U.S. Navy has 2 ships like this, converted tankers. Those are 1,000-foot hospital beds. One of those was off the coast of Mississippi after Hurricane Katrina. We used some of the beds on that ship to augment the hospitals ashore. Then we used the Comfort significantly off the coast of Haiti, and that's what I'll turn to next and talk about my sea story with deploying the same networks in Haiti. We were embarked on that ship when we first got out there. Then we were camping at the American Embassy at the Joint Task Force Haiti headquarters, working for the J6, the military senior communicator for the effort by the U.S. in Haiti, working for USAID. And then I went out and worked in the economy with the non-government organizations that were trying to work with and communicate with the U.S. military, and were having difficulties, and we wanted to see why. So this is our team leaving Guantanamo Bay, arriving off the coast of Haiti in a CH-53, the USNS Comfort sitting there in the background, and this is the deck of the USNS Comfort hospital ship. Anybody see what's wrong with this picture of this white ship with the red cross on the fantail? Right, there's a 50 cal machine gun there. Why is there a machine gun on the deck of a hospital ship? The point there is that's the world we live in, that in some places there are bad guys around us that want to kill us even if we have a white ship and a red cross. So we have to deal with on the ground being able to handle that force protection security challenge. There's where an airborne solution could keep our people out of harm's way, for example. This is the main palace in Haiti that used to be 7 stories. It's completely collapsed. The point of this slide is that right across the street was about 80,000 person refugee camp. 80,000 people in a park across the street there, living under tents and tarps and shelters that were becoming unrestless, and we had to set up communications in that environment. Being able to get up off the ground in the air would have made it a lot easier to set that network up. These are the scenes that you see in the streets. Try and imagine doing your job when the communications infrastructure is destroyed like those buildings and the telephone poles around them. 7-story hospital destroyed, collapsed, bodies underneath. Trying to find people in search and rescue mode without communications is a challenge. This is us at the embassy or at the airport and the UN facility starting to set up satellite services. Our embassy remained unscratched, built to U.S. standards. This is the back of the embassy with us with a satellite connection there and a headset on talking with Skype to the outside world. And this, similar to that earlier slide, the Comfort hospital ship had great difficulty communicating with the shore. They were using the bottleneck of their satellite on the ship to communicate up through the satellites to the internet backbone from locations on the shore rather than a ship-to-shore wireless network. A DACA would have allowed that ship off the coast to communicate directly with the shore and not have to deal with the latency from the hospital ship. And I think that is close to my last slide. This is just the scene in a hospital that was very overcrowded down there. And this is the main port that a U.S. Coast Guard security team was tasked with revitalizing. That was a 7-story crane. The whole port was closed down. We set up a Wi-Fi infrastructure down there for the Coast Guard and allowed them to do their job in addition to watch the Super Bowl last year. And they were very happy with that. 125-man Coast Guard team. This last slide here is just a busy slide. It's a shameless sales pitch for a capability that we have at the Naval Postgraduate School. We've got a National Guard base about 2 hours south of us in Monterey, that has its own airstrip and UAV fleet and hangar that DACA-type experiments and demonstrations could happen at. I've told Lee and Jennifer about these facilities down there. These experiments and demos happen quarterly, so we have regularly scheduled events that can test out these technologies. And that's.
Thank you, Brian. It's interesting that we were like ships passing in the night because we were at Katrina, we were at Haiti, we were living at the U.S. Embassy, but you guys, I see, were living high on the hog because we were living over in the parking lot. But thank you very much. Our next panelist is Dr. Edwin David, who is the leader of Advanced System Concepts, of the Advanced System Concepts Group at MIT, the Lincoln Laboratory. And as I said before, along with Brian, they hosted the workshop that we had there. So welcome, Ted, and I give you the floor.
Thank you, Richard. And I want to also express my thanks to the FCC for providing this opportunity to share some of our thoughts. The perspectives I'll share with you really combine perspective from the R&D community and from a boots-on-the-ground perspective that's born out of some of our work as technologists with the operations in Haiti, Deepwater Horizon, and also through a ongoing partnership with CAL FIRE out on the West Coast. I'll share a few different themes with you, some of which I've heard already through the panelists, and offer to augment some of those perspectives. One is on some of the context and assumptions around what might point to an aerial capability. The second one would be in what kinds of additional roles and potential benefits aerial has the potential to provide with comms as a baseline capability. And then I'll outline a few of the key challenges that we see going forward, and I expect to hear more on that on the later panels. So first, in terms of some context, of course, what we've heard is the overarching emphasis here to provide situational awareness across the mission set associated with a disaster response and recovery effort. And the thinking there is to move from a situation where you have very few in a response effort, such as at the upper echelons in command and control, having awareness and information that fans out to a broader community, to a situation where really everybody at some level is a decision maker, all the way across the echelons, up and down, particularly in the early stages of a response, when in fact the only decision makers may be those who can take action on the ground in their immediate environment. So that really points to a notion and a shift in thinking from thinking about comms, particularly aerial comms, as relays to to aerial comms as something that really provides the full-up, broad infrastructure that may be required. And we've heard some of those comments already. Again, an increased focus on being able to touch really everybody in the response effort at some level, particularly those that are first in. The other emphasis is on the ability to incorporate a very disparate set of information that may come from cell phones, text messages, and other networks that either are degraded but have been established prior to an event, or networks that have popped up as the event unfolds. All of these really point, again, to this notion of establishing cell and Wi-Fi-like infrastructure very broadly in the air versus in a piecemeal way in focused areas. So that's, going forward, one of the focuses. The other one is the need for deployability and rapid deployability. There's generally no knowledge, of course, of where something may strike next, and aerial provides the access to locations that may be very unanticipated, and also within a location access to specific hotspots that are in most need of more robust comms. Aerial has an ability to do that very rapidly. I'll also remark on the notion of flexibility, the concept that there's really no single system envisioned here, but rather the aerial platform as something, as part of an ecosystem, but one of the key enablers in that ecosystem. So we think a lot about new networks forming, the emerging role of peer-to-peer and ad hoc networking amongst smart devices. Well, what happens when that information wants to get out to the broader network, where information needs to be piped back to those networks? Again, a role for an aerial platform that can broadly cover multiple such peer-to-peer networks as that technology thrust moves forward in the future. And then, of course, scale of coverage. And this is mentioned in the white paper, of course. Just the sheer line of sight and scale of coverage that aerial affords is really one of the key considerations here. And that's something we need to consider going forward when we think of what are the kinds of payloads we're thinking about, and what is the platform size, weight, power constraints on such platforms. Not to lose sight of the fact that we would be going aerial to achieve a level of scalability, level of scope that is not present today. A couple other issues and themes. In terms of additional roles going forward, we talked about a gateway for ad hoc networks, the over-the-air delivery of new applications to smartphone-type devices in the midst of a response. That's a flexibility you'd like to have, and that's not enabled currently. It could also provide, with much of the same kind of technology, an ability to sniff out where are the hot spots, where does the communications want to happen but is not happening effectively, and if there's resource limitations on such aerial platforms, where can those best be focused? So that role of initially queuing such capability may be part of this suite. And then we get into other aspects such as geolocation and resource and asset tracking that have been mentioned. And the concept of the roll call and how that goes forward in aerial sense is very interesting. Challenges. So interesting to read the white paper thus far in terms of the response to the FCC's request for comment. Many of the responses tended to revolve around platforms and small UAVs, balloons, high altitude unmanned, deployable suitcases. I think that focus on platforms is great. It's interesting. It's a key element. I'd say going forward what needs to be looked at is, of course, the electronics package. There's an often implicit assumption that the electronics are there. It's just a question of packaging them for this new application. Big new issues come up, of course. Many of you know this when you go from using electronics that are designed for terrestrial use, putting them on an aerial vehicle. Can we really fit all the boxes we want, and on what vehicle? And if we do, what's the coverage and the scale that we get out of that? That's a key consideration. Are we talking about 1 or 2 platforms? Or are we talking about 50 or 100? Those really high-level trades need to happen so we understand the space we're working in. And then another key piece that we'd expect to focus more going forward would be on the RF front-end systems in here. So not just the electronics, but now you have an aerial platform, a very different radio frequency aperture kind of job that needs to happen to swallow the kind of data and push out the kind of data that we talk about in this application. Capacities of thousands of calls when you talk about a big New York, LA scenario, even 500 to thousands of calls when you talk about a smaller city such as Daytona or Flagstaff, what have you. So that RF, and thinking about the distance to the users, the high volume of traffic, whether you're in a mode where you're spotting a capability or you're surveying what's needed or providing a lower bandwidth but broader capability. And then the broader architectural issue of whether this platform is a bent pipe kind of model, where you're really relaying back to the comms infrastructure that's still maybe in need of repair, or it's the full end-to-end capability. Again, some architectural considerations. I think the phones, if you think about it for the cell phones for a moment, there's power there to take advantage of. You need to think about directional beam antennas, and that starts to limit your spot size. So the trade-off between what kind of gain you have at what range and how that impacts a whole response effort broadly and the bandwidth is something that's going to be key when we start looking at RF aperture. Thank you.
Well, Dr. David, we certainly look forward to working with you and all of the experts that you have available up at MIT to work through some of these issues that you talked about, and the other panelists also. Are there any questions for the panelists? Yes, sir.
My name is David Ward. I'm with the FCC. I work in the Public Safety and Homeland Security Bureau. I noticed from a previous slide that this Civil Air Patrol aircraft are equipped with the ability to radio relay high-band VHF, FM, and UHF.
Yes, sir.
The military tactical radios that the National Guard and Reserve use and are trained to use are 30 to 75 megahertz FM, which means they stay in the armory if you're going to use the CAP platform, and you have to issue them civilian radios. Also, you're restricted to a single waveform, FM. And what's troublesome to me is that these problems have been solved before. In 1998, the J6 Tango issued the Joint Tactical Radio System Operational Requirements Directive. And that, directive was, I guess I have to turn this on. That directive was aimed at fixing the problems of single waveforms and also fixing the problems of interoperability in single handheld man-packed vehicle, seaborne and airborne platforms. In 2003, the first of the $9 billion Army program was fielded in the handheld and the man-packs. And I was thinking that if you wanted to use even cell phones using a CAP device with a JTRS interface up there, you could do that. You can do that. So even people that did not have military police radios could still benefit from these aerial platforms if you authorize them to benefit from it. So I'm just asking, have you considered using the JTRS architecture to eliminate these interoperability problems?
No, sir. Specifically, that had not been considered. We were looking at single, very narrow missions, and the interoperability in the missions that we were trying to support, which were specifically first responders, firefighters, and the National Guard going door to door. We didn't look at a broader interoperability situation, and the JTRS never became something that we considered.
Any other questions? Were there any questions from the web? None? Yes, sir.
Jake McLeod, company called Graybeards. Question
Yes.
for Ted. Have you guys researched at all the use of backhaul with the photon backscatter technology, where you can get upwards of 100, theoretically upwards of 100 gigabit? Instead of, WiMAX is a good solution today. I think the photon backscatter is coming along nicely, but there may be a real potential for video transfer and such in a limited backhaul situation.
Right, to answer your question, there's active, not associated with this effort in particular, but there's active research, of course, and at demonstration level as well to explore the role and the potential that's there in terms of optical comms in general, I would say. And then there's a variety of techniques in that space. And it comes back to the model that it's another technology. So it comes back to the model for what this aerial platform really wants to do. Does it do a lot of onboard processing, redissemination, or does it need in which case perhaps the bandwidth requirements are lower for the outside links, the backhaul, or does it need the heavy-duty backhaul, in which case now that enters as a potential technology. I'd say right now, to the extent this is being looked at as a clean sheet, there's a variety of technologies, optical comms being one of them, when you look at that architecture. But there's a few different models for what that architecture wants to do that are going to drive the answers.
Okay, thank you. If there are no more questions, we're going to take a 5-minute break while the other panel comes up and we refresh the coffee. Jennifer, did you want to say anything? Okay, thank you very much, panelists.
And thank you very much for coming back for the second panel of our workshop today on potential deployable aerial communications architecture technologies. I'm Jennifer Manor. I'm a Deputy Chief of the Public Safety and Homeland Security Bureau, and this is an area that I've had the honor to work closely with many of you over the past few months as we've looked at these issues. This area has become even more interesting since this weekend because of the snow. I was actually evacuated from Shenandoah National Park with the rest of the folks visiting the park, and what was really interesting was the fact that there was no available communications in the park, at least where I was during that time. So this was a good example of where having access to something like a deployable aerial communications architecture probably would have kept some of the other folks visiting the park a little calmer, since there was no communications available at that time. So with that, we have a very interesting panel today, and I'm going to introduce each one individually. I'm not going to read the bio as Rich did because their biographies are incredibly complex and interesting, and they're contained in our book, so I'm just going to introduce people individually. Our first speaker is Bob Buckle, who's the CEO of Intelcom, who's been working on a very unique emergency response communication system that I've had the opportunity to see. And so with that, Bob.
Thank you, Jennifer. Is this working? Yes, it is. Slides. I practiced several things to say this morning, but listening to the first speakers, something has become very obvious, and maybe I should apologize in advance if I appear to be disrespectful or rude, but because of my accent I can probably get away with it. As far as I'm concerned, emergency first response is very specific, and it lasts for just about 60 minutes. I think everybody's familiar with this golden hour. And if you can't actually get response out to people in a disaster situation within that golden hour, you're actually recovering rather than reaching out to people to participate in their survival. So with absolutely no disrespect to things that we've heard, if any of the infrastructure that's required to support a first response takes more than about 30 or 40 minutes, then quite honestly you've missed the opportunity. And again, with the best and the deepest respect in the world, I'm a pilot, I know what it takes to get an aircraft off the ground. That alone can take an hour or so, and to get on site can take even longer. So what I've been looking at for the last 7 or 8 years is what I consider to be a first response system, and that allows the first responders to actually be communicating in some instances even before they get to the site of the disaster. You've talked about all sorts of technology and some of the newer wonderful communication systems. I've heard a lot about Wi-Fi, smartphones communicating. There is a piece of technology that's been available for some time which is absolutely ideally suited for, guess what? Voice communications. It's specifically suited for that. It's been designed for that. It's been designed to allow lots of people to talk to each other in a fairly restricted area. And that's called a cell phone. Now, when I've spoken about this before, there's obviously the first suggestion, well, the cell phone towers go down and you lose power, you lose the infrastructure. What we've been working on is a system which we've glibly called a autonomous radio network. And effectively what it allows people to do is to take their own cellular tower with them. Historically, these have been big systems. And by big systems, I mean a suitcase system. Today, we're talking about fairly tiny boxes. Typically, this is the size of the autonomous radio networks that we talk about. Now, these are good for communications up to about 40 or 50 individuals. And it's got a reach back on there, and it reaches back to an aerial platform. That aerial platform isn't a balloon, and it's not a little aeroplane or indeed a UAV. It actually reaches up to satellite. And despite some of the things that have been said this morning, the satellite system that's actually very appropriate for this is in fact LEO satellites. There just isn't the time or the ability to start deploying VSATs in an emergency first response situation. LEOs provide a reach-back capability perfectly capable of supporting the type of communications that's required for that first response. So essentially what we do is we provide these type of systems, and typically a team will go in, and that team may consist of a dozen or so individuals. This provides the infrastructure to allow them to communicate with each other. It also gives the opportunity to reach back. And these things are smart. They can figure out if there's another one of these little systems around. If it is, they mesh together and they start to provide a wider communication path to allow the first responders to talk to each other. I mean, I can run through some of the parts on the slide. The ranges go from, as you see, 100 meters up to about 30 clicks. They mesh themselves together. Again, no disrespect to what we've heard this morning, sticking an AP up on an aircraft certainly will give you some communications. The good news is the aircraft will give you quite a good footprint. In fact, the higher you get, the wider the footprint. The bad news is that you're now sterilizing that footprint in terms of its communication capability. And if you've got many, many dozen little Wi-Fi clients all trying to access the same AP, you've got a real problem. Cellular phone companies are very familiar with what's called the dirty secret, which is cell breathing. And cell breathing effectively is where you've got many, many systems all creating noise. So indeed, you could have an aircraft or a balloon with a very, very capable access point. Unfortunately, on the ground, you're stuck with some fairly unsophisticated communication Wi-Fi systems. 2.5 minutes, so let me just bash through very, very quickly. We can easily think about deploying specialist communication equipment for these instances. The reality is it probably won't happen very, very quickly. And today, pretty well everybody has got a cellular phone. If you haven't, you walk down the road to Kmart and you buy one for $9. You've got yourself a very, very capable communication device. Running out of time, so I just want to very, very quickly move through some of the advantages. The system actually allows you to pre-register specific individuals. That'll prioritize them, which means that you put the cellular system on, it doesn't immediately become overloaded with many, many people trying to access it. It's specifically there for first responders. It allows you to do lots of things other than just voice. You can broadcast situation awareness, you can broadcast to groups, you can broadcast to closed user groups, or many, in fact, everybody that you care to broadcast to. Running out of time. The other thing that it can do, because it's based on COTS technology, although in its first mode it will allow the first responders to talk to each other, it then has the capability of being switched into public access mode. So God forbid that you've got a collapsed building with people in there. There's no infrastructure. What you can do is you can instruct your autonomous network to go into what we call masquerade mode. And that will allow any handset that's within the range of the system to be able to communicate. Now you've got the ability to talk, send texts, or indeed ask the people to talk to you. The other thing, of course, is because it's RF, it also gives you not a very high resolution, but it certainly gives you the capability to start to do some position fixing within the building about where people are. 40 seconds left. The only issue really that we have to consider is how the thing is licensed. In Europe, there are a couple of countries that have emergency frequencies that are allocated or are allocated as and when an emergency is declared. Here in the US, there's one organization that could do this coast to coast, and that's the FCC. So if the FCC wanted to today, within the next couple of weeks, they have the ability to allow this type of technology to be deployed now, so that, God forbid, the next Katrina happens, the infrastructure is already there. Everybody is carrying the ability to be able to communicate. Bang! How's that?
Thank you very much. Thanks very much, Bob. And I think what's really interesting about this panel is you're going to hear from all different types of technologies. So next I'm going to introduce Jerry Noblack. Jerry is the co-founder, chairman, and CEO of Space Data Corporation. And just incidentally, Bob was here a few weeks ago, as was Jerry. We had a technology demo for public safety, and Jerry had brought one of his platforms, a weather balloon. So with that, thank you for bringing that. And then
thank you, Jennifer. Today I'm going to talk a little bit about space data's high-altitude platforms and their deployment with the U.S. military and how they could be leveraged into these disaster scenarios. Space data specializes in lighter-than-air communication systems that operate in the near-space layer, basically the layer of the atmosphere above airplanes, below satellites. Essentially, our platforms are 20-mile-high towers that can be deployed in luggage on a commercial aircraft and erected within 2 hours. They are based on the heritage of weather balloons that have operated for decades, but they add an altitude control system to allow wind steering. Space Data has 3 classes of platforms. The SkySight has been providing commercial machine-to-machine coverage to the oil industry for 7 years now. The SkySat has provided communications for beyond line of sight, comms on the move to the U.S. military for the last 5 years, And the Marines also deploy it in a tethered solution up about 400 feet when the wind conditions are favorable. And finally, recently we developed the Sky Eye, which provides remote imaging from near space altitudes. The systems are very well proven. They have over 5 years of operation on a 24/7 basis, over 250,000 flight hours of operation. They've been deployed by the U.S. Air Force, the Marine Corps, the National Guards, across operations that have spanned 5 different continents, from the equator to north of the Arctic Circle in various climates. The systems are also very flexible. They provide satellite-like service to the existing terrestrial handsets and have done this in bands from VHF to 5.8 gigahertz and have done it in various digital wireless protocols, including APCO P25. Our platforms provide wide coverage to existing terrestrial equipment and are fully compliant with existing FAA rules. The coverage diameter is really not a function of the propagation, but the timing limits that exist in various wireless protocols. In a machine-to-machine environment, you can get 420-mile diameter of coverage. In 2 or 3G voice, you can get about 170 miles of diameter coverage from one of these platforms. In 4G, you get 120-mile diameter coverage. It takes about 15 minutes to launch and prepare a SkySat for launch. As you see in this video, the National Guard in Arizona launching one from the side of the road. It takes 60 minutes to get to 60,000 feet. Then typically the platform spends 12 to 24 hours at altitude before it runs out of batteries. A new platform is launched to replace it, and it parachutes back to Earth where it can be recovered and reused. 2 individuals out of the back of a pickup truck can launch 6 of these platforms with enough supplies in an open field and 40-knot winds. They operate under long-standing FAA regulations that govern weather balloons that have existed for decades without any mishap. And those regulations permit 2 6-pound packages to be launched on the payload without any restrictions. While other unmanned aircraft have to wait for sense and avoid technologies to become available, our system does not need that because other aircraft have to avoid weather balloons. The existing National Weather Service launch sites also provide another logistical thing to advantage. There's 100 of those that could be used to launch these platforms. For protocols without timing limits, up to a 600-mile diameter of coverage can be provided. The systems can launch from outside the affected area and float above the highest thunderstorms of hurricanes. So they can actually be on station even before and during a hurricane, so the first response can start as soon as the winds calm down. The National Guard in Arizona has deployed 2 exercises, one in Hawaii a couple years ago where 1 SkySat covered the entire islands, and another one along the Gulf Coast where 2 covered the entire affected area from Hurricane Katrina. The higher altitude of these platforms provides better spectrum reuse. By being up higher, you can use a narrow beam antenna, and you take advantage of the antenna pattern, restricting the use of the spectrum to the affected area. At lower altitudes, you of course need to use a wider beam antenna to get the same area, and this creates wide side lobes that can spread the frequency use and interference farther afield in the disaster. The systems are unlike a free drifting balloon in that they have altitude control. And this altitude control allows you to basically change altitudes and take advantage of the various wind layers in the stratosphere to drift back and forth across the footprint of a disaster area. The platforms are also very stable and can point a directional antenna to basically spotlight the communication coverage into the disaster area to keep the interference controlled from going outside the disaster area. So while we can provide coverage to a 600-mile diameter circle, we can actually restrict that coverage to about 1/10 that diameter. A recent example of this is an APCO P25 demo in Texas under the Coalition Warrior Interoperability demo last June, where the Texas National Guard talked from Austin, Texas to El Paso, thus proving that incident commanders in the capital can talk to directly to a disaster area anywhere in the state of Texas. And if you know anyone from Texas, you know it's a big state. 2 recent examples show coverage over Washington, D.C. In August, General Pollitt, Director of DISA from the U.S. Army, launched a SkySat from the Baltimore Convention Center, which got to altitude over Annapolis and drifted west over D.C., providing coverage from Ohio to New York to North Carolina. Then about a month ago at the last FCC open meeting, we provided 900 megahertz coverage from the FCC here to a near space conference in Norfolk, Virginia. The platforms also can provide coverage to provide communication and imaging after a disaster. Since they're 25 times closer than the closest satellite, they can provide coverage that allows you to identify people on the ground with even small commercial cameras, and they've proven the ability to, in the middle of the night with infrared, provide coverage and disaster assessments. This coverage is transmitted to the ground over point-to-point broadband links. This table shows the coverage and the cost of various platforms, from the tallest tower up to the highest geostationary satellite. The tallest tower is $3 million to build, and over a 30-year life only costs $21 an hour, but those towers are often unavailable after disaster and aren't portable. Various aircraft that the military uses cost thousands of dollars per hour to launch. A geostationary satellite costs about $250 million to launch and about $2,400 over its 12-year life. Our platform costs the military on the order of $10,000 a payload, and that's $800 an hour if they dispose of the payload with no recovery, which is the military approach. In a disaster situation, you can typically recover these, and the cost to launch is about $100 an hour. Of course, wide area communications requires wide area frequency allocations. This is possible now that many systems are being narrow-banded. A decade ago, the FCC and the NTIA suggested 40 channels that could be used for interoperability in a disaster, and Space Data has about 40 narrowband 900 channels that are available nationwide that could be made available for this purpose. So in summary, the systems are compatible with terrestrial devices. They make commercial devices on the ground work like satellite devices. There's no new device to learn, carry, or train up on. There's lower cost that extends the lower power that extends the battery life of the radios. They can operate the lowest transmit power and still get this coverage. They're responsive. 2 people can deploy in commercial aircraft and check luggage and fly and operate one of these and light up a big western state in 2 hours from an open field and 40-knot winds. There's very good access because they're not launched from the affected area after disaster. They provide secure encrypted communications, and the interference can be controlled by using narrow beam pointable antennas. They've been demonstrated across multiple frequency bands and multiple digital wireless protocols and operate in all weather conditions. The military version is production now and deployed worldwide. And while the systems are small, as technology migrates from macro to micro to pico to femto, the capacity and services that are available on these platforms increases every year. Thank you.
Thanks, Jerry. Next, we'll hear from Penny Rubel, who's the director for the Arkansas Wireless Information Network of the state of Arkansas. And we're very happy to have Penny here since she's actually a user of these systems, so she can give us a little different perspective as well. Thank you, Penny.
Thank you very much, Jennifer. It is a pleasure to be here, and I do appreciate the invitation to speak with the group today. Can we get my slides? There we go. I'll be providing information today on the type of deployable aerial communications that we have tested in the state of Arkansas. While it is not the purpose of the Arkansas Wireless Information Network to develop new technology, it is our purpose to provide uninterruptible communications to the 17,000 public safety personnel that use our system. I hope that the information that we share today and the discussions today will be useful to the Commission in sorting through the regulatory issues and determining next steps for pilot programs and implementation of deployable technologies. Before I get too far into that, I'd like to tell you guys a little bit about AWIN and what we do. AWIN is a 700-800 digital trunked radio system. We have 109 remote tower locations. We have 2 master sites and 1 master site that is a standby site. The backhaul for the system is primarily microwave. As I said earlier, we serve 17,000 first responders, and they rely on us to provide both day-to-day and emergency communications. We have 923 agencies that use AWIN. 810 of those are at the city or county level. The Arkansas State Police represent the largest single entity with approximately 3,000 units in service. AWIN is multi-jurisdictional and multidisciplinary. Every county in the state has at least command and control operations on the system. All emergency disciplines use AWIN, so we have law, we have fire, we have emergency management. We also have our state's trauma system uses AWIN for their trauma communications. To ensure interoperability, each radio is required to be programmed using both federal and state interoperability channels. We further require that these channels are programmed in the same position on every radio so that if we have to deploy cache radios during an event, there's no confusion about where the interoperability channels are. Our goal is to ensure that Arkansas's first responders are never without the ability to communicate. And that is what has driven us to look at deployable aerial communications. The illustration on this slide shows the position of Arkansas on the New Madrid fault line. And as you can see, we are at a significantly increased risk for damage to the A1 infrastructure if there is an earthquake in this area. So in preparation for such an event, several Arkansas agencies came together to test aerial communications. So my next few slides talk about the equipment used in the test plan and what we learned from that. Now, I don't want to sound like a sales pitch. As I said, we're not in the game to develop new technologies. We use the standard off-the-shelf system. It was not custom built. It's not. There's nothing special about it. As you can see from this slide, we used a Motorola PDR 3500 suitcase repeater. This equipment operates on a Quantar platform. It can be used as a base station or a repeater. We tested in the 800 analog mode, but we understand that with additional software and programming, the unit can be made Project 25 conventional. Earlier versions of this equipment weighed over 100 pounds and were a little bit harder to deploy. This particular equipment, the suitcase is 43 pounds and one person can move it and set it up fairly easily. So the ability to quickly deploy communications equipment is essential in a disaster, obviously, but being cost effective is essential to us every day. This solution we feel like it's particularly cost effective since it does not have to be deployed aerially. It doesn't have to be sent up in an airplane. It doesn't have to be sent up in a balloon. It can be mounted on the top of an existing building. It can be taken to the top of a mountain and deployed. It can be deployed anywhere where we can get power to it. The unit ships with a standard AC voltage and 12-volt DC adapter cable. So it could literally be ran off a car battery if we had to. In Arkansas, it's particularly important to us because we have big national parks. We have a lot of state parks. People come to Arkansas to do hiking, so we end up having a lot of search and rescue activity. So this kind of very quickly, easily deployable equipment is important to us. So kind of the proof of our concept was we wanted to test based on worst case scenario, and for us, obviously, that's earthquake. The test was conducted on one of the National Interoperability Repeater channels, so the NIPSPAC channels. The equipment was flown in an Arkansas State Police-owned C-130 at an altitude between 6,000 and 9,000 feet, and the flight path went across the northern one-third of the state. The test lasted approximately 2 hours. During that time, state police performed roll call and was able to successfully communicate with all parts of the state. So based on that test, we feel like that this is a viable option for us and that we want to go forward with additional testing. Several good points came out. Obviously, we were able to prove the statewide communications. We had no reports of interference. The calls were very clear and very easy to understand. The antenna mounting location, they did work a little bit with where they wanted to mount the antenna. Of course, we learned that putting it on the bottom of the aircraft was the best location to eliminate problems with signal. And one of the best things for us is that radio personnel were not required to be on the aircraft. Once we got the equipment in the aircraft, got it set up, the radio personnel could be deployed somewhere else. So in a disaster situation, that's very important because we need that help in other places. So looking forward, we'll be very interested in seeing the outcome of this workshop and working with the Commission on future projects. Specifically, we would like to move forward with additional testing involving our Civil Air Patrol and additional state and local first responders. We're also looking forward to new technology that would allow for connecting a digital wide area repeater back to the AWIN system. This connection would allow our first responders to take advantage of full interoperability of their existing equipment. Further, we are interested in the use of radio-controlled drones and blimps. We believe this would add to the cost-effectiveness of our current approach. And finally, a couple notes that are not on the slides. The PDR 3500 is not FAA certified for use in aircraft, so we recognize and support that one of the considerations going forward will be that coordination with the FAA. If the NIP specs are the channels of choice for this type of operation, it may be advisable to dedicate one of the NIPS PAC channels for deployable air communications to ensure that there's no interference with aerial communications and events going on the ground. So I was glad to read in the Commission's white paper and in Director Cannon's earlier remarks that included deployable aerial communications and critical to a disaster response. In Arkansas, we wouldn't deploy a suitcase repeater to every disaster, and we certainly agree with the Commission that deployable aerial communications is going to be another important tool in our communications toolbox. So that wraps up my comments, and thank you very much for having me here today.
Thank you so much. And with that, I would like to introduce, and I hope you get your name right, because I just realized, Ted Wierzbowski.
It's Banowski, and ask where is Banowski and say it fast. Where's Banowski?
Where's Banowski? Okay. I think it doesn't work with a New York accent. He's the director of UAS Aerospace Integration I'm not doing well pronouncing anything. How do I say it?
AeroVironment.
Thank you.
Slides, please. Just going to talk a little bit about platforms today that are available or will be available soon in the UAS arena. Talk a little bit how they got developed and what they're being used for right now in Iraq and Afghanistan and other places around the world. So, talk a little bit about evolution, our small UAS inventory, as well as a new airplane that's being developed called Global Observer. So, I'll get through this pretty quick. AeroVironment's been around a long time. The company was founded by Paul McCready. But we started developing small and high-altitude long-endurance aircraft decades ago and have now supplied, if you look over here, this is a Raven. That's a full-scale model of a Raven. We've deployed over 18,000 of those in theater and around the world. So we build a lot of small UASs. We've done a lot of demos, communications relay demos, primarily in the military arena, and have done some in other arenas. And as you'll see later, it's really the payload and the spectrum applications that we're going to need to worry about with these platforms because they're available right now. I'm going to give a quick overview now of how these things evolved. Back in the mid-'80s, we, AeroVironment, decided that it would be good for the foot soldier to be able to look over the next hill, developed an airplane called Pointer, and sold a few of them, but after 9/11 we went from 1 aircraft a month to 15 a day. They were found so valuable by the foot soldiers in country. We saved numerous lives a day with these systems, primarily using EO/IR cameras that are mounted on the airplanes. So today we have Wasp, Puma, Raven. Well, I'll show you a little bit about that in a little bit. And then we've also been working for decades on high-altitude long-endurance UASs. Started in early 70s with we built the first human-powered airplane. Then in the 80s we did a solar-powered airplane, flew a solar-powered airplane up to 100,000 feet, and am now developing an airplane called Global Observer that I'll show you a quick video clip on. This is our family of small UASs. It's actually a family of systems. They're all operated with a common ground control station. You'll see the ground station right over there. It's very simple operation. The foot soldiers that normally operate these things are guys that have been brought up with PlayStations, and so they know how to operate these things. They learn how to do this. It usually takes a week to 2 weeks to be fully qualified to fly one of these things, and that's with all the tactics and procedures they need to look at and learn. Puma is probably the airplane that would be most applicable for what we're talking about here, but we have done demonstrations with Puma and Raven. Wasp is a little bit smaller. This is how we envision that, and we do this actually today. We have a system on the airplane called Digital Data Link that basically each airplane's an IP node in the sky, but where you would launch the airplane with a relevant payload and act as the comm relay, and we can also talk between airplanes. So that's how they would be used. I got a short video. I'm not going to run it all the way through, but just to show you how easy these things fly, if the video comes up. There we go. They're all hand-launched, so you just pop them into the sky. It takes a few minutes to get it ready to fly on the ground. They basically fly themselves. You can put in GPS waypoints, you can make it orbit, you can do all kinds of interesting things through our mission planning software. But very easy to fly. It's not like a radio-controlled model where you actually have to hand fly the airplane. It's pretty easy. Recovery, all of them just come down, you press a couple buttons, they do a deep stall, land on the ground, usually break apart, put them back together again, put in a new battery and go off and fly again. This is a landing of a Raven, and it literally only takes a couple of minutes to turn the airplane around, and they all have, when they fly in country, they have thousands of missions on them, so they're very, very rugged, built in order for our foot soldiers to fly them in Iraq and Afghanistan. So with that, I'll go into Global Observer. It's a high-altitude, long-endurance UAS that actually, as a result of decades of work, it can fly up to 7 days above 50,000 feet, and with a fairly heavy payload that we think could be developed for this kind of application. I'm not going to talk too much about it. I'm going to let ABC do that with a little bit of video of the airplane flying and what it can be used for.
The Pentagon has been quietly testing a new high-tech unmanned plane, and ABC's John Hendren recently went deep into the Mojave Desert to get an exclusive first look.
This is how aviation history is being made. Slowly, silently lumbering into the stratosphere, an unmanned spy plane that will soar higher and stay up longer than anything in the air right now.
The aircraft weighs about as much as a large SUV, but in order to fly so high for so long, the wingspan has to be enormous, about half a football field. That way, even though you can't see it, it can see you.
Like a satellite, but for a fraction of the cost.
A large geosynchronous satellite, billion plus.
So we're talking, to buy a plane like this, tens of millions as opposed to hundreds of millions.
Correct.
The manufacturer, AeroVironment, gave us an exclusive look. During this test, the Global Observer flew at 6,000 feet, but on the job it'll fly at a stratosphere skimming 65,000 feet, twice as high as Mount Everest, and from there it'll be able to see 600 miles in every direction, enough to cover the entire country of Afghanistan. And that has implications for more than just the military. On 9/11, the company says it could have restored communications within hours.
All the cell towers in that whole area of New York were out. Immediately, a platform like this could be flown over and parked over New York and restate the communications infrastructure.
The Global Observer can also fly longer, hovering up to a week at a time, while current planes land after 30 hours. That's because it's powered entirely by lightweight liquid hydrogen fuel with zero pollutants.
So what does it emit?
Water vapor. So it's hydrogen and oxygen, H2O.
Within a few years, the military could position these planes around the globe, tracking enemy fighters and instantly supplying communications to American forces on the ground. And at home, tracking dangerous storms, western wildfires, or perched high overhead in a disaster like Hurricane Katrina, linking first responders and searching for survivors in those first precious hours. John Hendren, ABC News, Edwards Air Force Base, California.
So with that, our feeling is that UASs or UAVs, they're a viable platform for what you want to do in DACA. The small UASs are available now. Global Observer, high-altitude, long-endurance UASs will be available soon. However, there are going to be technical issues, and it's going to primarily be with the payload, spectrum and size, weight, and power, and what do you really want to do with it. It was talked earlier in the previous session. It's really going to be a family of systems, UASs, balloons, ground stations, whatever, that you can bring together to actually bring this capability to our citizens. So we look forward to working with the FCC and other partners, payload partners, and hope to bring this DACA to a reality. Thank you.
Thank you very much, Ted. So before I open the floor, I was going to ask our panelists a couple of questions myself, and I was wondering if there are any real-life examples that any of the panelists can provide where DACA technology has been used to restore terrestrial communications, and how have they worked?
We have several systems deployed Primarily they're for places where there was no communications. However, in a lot of instances there is communications, but for various reasons they're not desirable to use the public infrastructure, in which case in most instances the systems that we provide actually, as far as a user are concerned, are completely and totally transparent. So the answer to your question is we have got these systems deployed in many places around the world to both restore and provide from scratch infrastructure.
Thank you.
I think for space data, the most recent example is the 26th Marine Expeditionary Unit was using our system off the coast of Libya when the no-fly zone was established back in March. In the early days of that, an F-15 crashed, and they had to go in and recover the pilots. And our system was the communications system that allowed those Osprey and helicopter to go in. And of course, the war in Libya had already wiped out all the communication structure terrestrially.
Thank you.
And on the small side, with the digital data link on all of our small systems now, it's voice over IP. So in country, they're being used as comm relays. So,
okay, great.
but not for specific disaster response.
Okay, thank you. With that, let me open up for the floor. Does anyone have any questions? Yes, sir. Do you have the mic? Well, do you want to use the microphone? And if you could just identify yourself first.
John Coleman, XG Technologies. Can you tell me what frequencies your systems operate in? Yeah.
COTS frequencies. Primarily, we tend to use the old 2G band plan, 900 being the preferred, 1800, 1900. We choose to use COTS frequencies so that it is compatible with COTS phones. However, we do have an allocation, we do have an ATC allocation, but that then suggests that the handsets themselves have to be either modified or special. So in the instances where we're using them, we use them in cooperation with the local incumbent operator. And that usually works pretty well. The suggestion is that, again, it takes time to coordinate those sort of things. So with the FCC's help, the suggestion is that as an emergency is declared in a specific area, then the frequencies would be allocated. And these are smart. In other words, they will deploy themselves over a big geographical area, but if they see another one, they will actually reduce the size, they will reduce the transmitting power. And they do what cell systems are designed to do. They allow the reuse of frequencies over and over and over again.
And Ted, what is the payload of the GO1 supposed to be?
Around 400 pounds with 2.8 kilowatts of power available is what we're shooting for. Right?
Thanks.
Mm-hmm.
Other questions? Okay, well, I'll ask some more questions then. Is it possible to support multiple radio communications technologies using the platforms that were discussed today so that existing devices will be used on the ground? So for instance, in my evacuation from Shenandoah National Park, would I be able to rely on a DACA to reach my cell service provider?
Space Data has launched various applications, including CDMA in the past on standard 1900 megahertz spectrum. We've also made interoperable demonstrations. It was talked about earlier how some platforms have AM radios, aircraft, and the people on the ground have FM, and we've flown systems for the military where we map the AM and the FM together so those two groups of users can talk to each other without having to get provision new handsets.
One of the things that we've been working very, very hard on is to utilize some technology which our friend I think will speak about later on today, which is software-defined radio. That gives us the flexibility to be backwardly compatible with pretty well all systems, but most importantly it means that infrastructure, if you've paid for infrastructure, it's not going to be outdated overnight. So most of our systems now contain at least one SDR, and within the next 18 months all of our systems will be based primarily on SDRs.
And with that, unless there's any more questions, we'll take a break until about 10 after 11. We'll commence with our third panel. And thank you, everyone. And thank you to our panelists.
Dio, Chief of RF Engineering here at the Emergency Response Interoperability Center. And welcome, panelists. It's an honor to have you here today. As a treat, I'd actually like you to introduce yourselves and give a little bit of background on your significant experience with deployable communications, if you could. But the trick is just to take a minute, so because we have a lot of information to cover. So if we can start with Dave.
Yeah, Dave Buchanan. I'm representing NIPSTIC. I'm chair of the Spectrum Committee, but my background is with the County of San Bernardino in California. It's about a 20,000 square mile county. To give you some perspective, you can put Maryland, Rhode Island, Delaware in it and have lots of room left over. We have a lot of different disasters, problems out there, and so I'm very familiar with trying to bring communications and keep communications going in a disaster. Okay. Did you want me to go ahead with the...
No,
okay.
let's just go one by one with each panelist, if you could each just take a minute. Thanks.
I'm Jim Bugel, Vice President of Public Safety and Homeland Security for AT&T, and quite frankly, most of my experience has been with earthbound terrestrial restoration efforts. Haven't had much experience at all in aerial, so we appreciate the FCC putting on this workshop in order to learn and understand what potentially is out there.
Thanks, Jim.
Daniel Devasirvadam. I'm from SAIC, Science Applications International Corporation. I have a background that started with HF and then went on to mobile communications and then SATCOM. And then I've been in public safety communications for the last 10 years or so. I've been involved with ACCO and many of the other organizations. And I was one of the people who made a submission on the original DACA request. Thank you.
Thanks, Daniel.
Al Johnson from the DoD CIO office. Background is 20 years of active duty service with the Army and tactical communications. Been on both the planning and the receiving end of a lot of airborne communications and the types of things that DoD does in that arena that has already been mentioned by previous panels, and working a lot in disaster response and information sharing issues associated with disaster response.
Good morning. This is Brian Joseph. I'm Assistant Vice President for Regulatory Affairs with CTIA. We represent commercial carriers as well as infrastructure manufacturers and device manufacturers for the commercial wireless industry. My areas of responsibility traditionally have been in spectrum as well as infrastructure, and certainly CTIA's efforts coordinating with carriers on business continuity and disaster recovery efforts. So looking forward to hearing from my other panelists, and certainly enjoyed the earlier panels for good perspective on this issue.
Thanks, Brian.
I'm Mike Roberts with Coco Communications. My engineering background goes back about 25 years, and I've been working with peer-to-peer and mesh and MANET networks since the early 90s, before those terms were actually coined. Currently, I support Coco Communications, who does applications in that space, including some work for the Air Force, which is specifically geared towards enabling advanced aerial networking in the DoD. So we'll share some perspectives on that with you shortly.
Thanks, Michael. Okay, so this panel will address technical issues associated with the deployment and operations of DACA technologies, including the potential for harmful interference and the need for spectrum coordination, licensing and authorization issues, and standards development. More specifically, ahead of time, I've given the panelists some questions within these areas, and they are the following. I've asked them to look at the most appropriate SATCOM and airborne relays and what frequencies to use and why. I've asked them to identify and comment on avoiding interference, i.e. coordination from elevated relays to existing and still operational ground infrastructure, so that their operation is preserved with no additional harm or disturbance. And in addition, I've asked them to comment on multi-protocol considerations to enable optimal relay and interoperation to accommodate the wide varieties of communication on the ground. And finally, I've asked them to comment on ad hoc or peer-to-peer mesh networking between relay craft to extend the reach of DACA systems. So I've given them these focus questions ahead of time, And I believe I'll turn it over to Dave, who can start in on the first presentation.
Okay, thank you. Glad to be here. Well, it came up before.
Yep, there you go.
Oh, whoops. Okay, it's gone. There we go. Anyway, I'm going to focus today mainly on Part 90 voice communications for public safety and some of the issues if you're going to do aerial deployable. I do think it's a good tool, but you're going to probably think some of this is rather negative, but I really just want to point out some of the practical issues of trying to deploy these. And to point out a few things, most disasters do not result in widespread outages. If you look at the vast majority of disasters, the two-way systems, or the land mobile systems for public safety, are still working. I can give you a few just from my background in my area. We had 1980 Panorama fire, wildfire in San Bernardino. 300 homes were lost. We've spoken a lot about earthquakes today. Actually, some of the largest earthquakes in recent times have been in my county. The 1992 Landers earthquake was a 7.3 magnitude. There was it triggered a Big Bear earthquake, which was about 6.5, and then of course the Northridge earthquake in '94. And we also had another earthquake out in our desert. The Hector Mine earthquake was 7.1. All of those earthquakes didn't result in any outages that I could find. Well, I know the ones for San Bernardino, but the Northridge, I asked the folks out there, and they said no, the communications still kept going. The wildfires we have all the time. 2003 was the last really big ones, San Diego and San Bernardino fires. There was a couple individual sites lost, but not widespread. I checked with Steve Devine. They just had the tornadoes back there in Missouri area. Again, they had a lot of problems, but it wasn't with the sites going down. So the thing that triggered with me was, sorry, I should have had this one up here. Public safety frequencies are, Part 90 frequencies are shared. They're reused heavily, sometimes with quite close spacing. So any airborne deployment can interfere with other licensees that are still operating. That's one of the things we want to keep in mind. We just can't put up some aerial deployment that helps in one area and destroys another area. That's not going to be helpful at all. It's going to require some very good frequency pre-planning to be, it's going to be vital to the success of using this equipment. If we don't, we're just going to cause a lot of problems. To give you an idea, here's some Longley Rice studies that I did just to give an idea. This is centered in the San Bernardino Valley area. We're adjacent to LA County and LA City. In fact, if this was to deploy something in my county to help us out, we'd have to be sure and not interfere with LA City, which is only 35 miles away from our border. And I showed this at 150 meters. That would probably work. But if you go and look at it now, where the red is showing up there, that would be an interfering level. The green is of course the coverage area, and that would probably wipe out the City of LA's operations. So the height is very critical on this stuff to keep down interference, and I was using just 10 watts of ERP on this. So just to give you an idea, it doesn't take much when you get up high to interfere over a wide area. Some ideas. I think we need to limit the height above ground unless you're doing something very special on a dedicated channel. If we're trying to use our day-to-day, even interoperability channels, the height above ground is going to have to be limited. We should probably limit these to interoperability channels, and of course limit power, which is probably inherent because they have the payloads are not that great anyway, so power is going to have to be limited. I think as far as specific voice channels, the 700 interoperability channels are the best place to use these, assuming that there's available equipment in that area. Some areas just use VHF, so that may not work unless there's a cache of radios. If there was some way to possibly get DHS or someone to fund a cache of radios that could be brought in with the aerial deployable equipment, then that would be a great way. Other than that, VHF is widely used, but we have to be very careful. There's not very many channels available for VHF interoperability. I think we need to involve the regional planning or the SIEC committees in each state to plan this out ahead of time if it's going to be successful. Just bringing it in on the spur of the moment will probably cause as many problems as it solve. And obviously, as I said, require a pre-plan before you do these aerial deployments. I think that's going to be very critical to this. Aerial deployment, it can be good. It's another tool. Always when you're planning how you're going to keep your communications going or restore them in a disaster, you want a lot of tools in your toolbox. You know, we have portable repeaters, we have cells on wheels, we have trunk-mounted repeaters or trunk transportable sites. They've been very valuable. In my system, we have a 5-channel trunked system that we can use anywhere in our county, and it's probably the tool that we use the most. Amateur radio, trailer-mounted generators. I think it's been said before that I heard earlier in the panel, and it's true. Power is probably the biggest problem of keeping your communications going, and trailer-mounted towers. So this gives us another option. It would be good to add this option. I would just caution that we carefully plan it out and we know ahead of time of which frequencies we're going to use it on, and make sure we don't cause more problems than we solve. Thank you then. Thank you, Dave.
All I got is myself.
Oh, there it goes. They brought it up.
He brought it up. Thank you. I'm going to speak basically from a commercial mobile provider standpoint, commercial services. I also want to kind of support what Dave said, that obviously aerial deployments could have benefit, but the coordination and planning is key. There's a couple things here that have been brought up before today. If there was to be an aerial deployment of commercial mobile services, they would have to have 2G, 2.5G, 3G, GSM, UMTS, LTE, CDMA 2000, because in the affected area you're going to have all those handsets that are going to be out there. The key limiting factor is number one, frequencies, as has been discussed before. If you're covering a very broad area, either you can do that with a number of different ways, but the amount of traffic you're going to be able to actually broadcast is going to be limited, and it's going to be significantly limited by the amount of backhaul off the aerial platform. The amount of how that backhaul is provided is going to be key. I mean, there's a number of different ways to look at it. You can do it via satellite. You could do it, I guess if it's stationary, you could do it via microwave. If it's stationary and low altitude, you could actually do it via coaxial cable. But there's a number of different there's a number of different ways to do it, as people have discussed today. but that's going to, depending on the distance, will cause timeouts in those sessions. You're going to have some latency there. The benefits are that if you have an area that's heavily impacted and you have a DACA system that's up there, it can have a home location register. Let's say you have multiple licensees that are actually on the same platform. Their customers will be able to access the system. For those that aren't customers, they will go into SOS mode. The handset will go into SOS mode, which will allow them to access a like-banded DACA, so they could access 911. CMAS or plan would be available via DACA network through cell broadcast, which would also be a benefit. But again, one of the other limiting factors is alternative link budgets and power management. Our cell sites, the smallest that we can get the components down to right now, is about 240 pounds. Of course, it's getting smaller, and we require anywhere from 100 to 200 amps to run a cell site. And again, getting back to power, how long can you provide that power in an aerial platform? Potential harmful interference. Obviously, as Dave mentioned, coordination is the key issue. It depends how wide. It depends what the propagation design of the aerial platform is. Obviously, in a disaster, our primary objective is restoring the assets on the ground. As has been discussed, there may be times where that's just not possible. If that's not possible, then this may be the appropriate tool. But as those assets on the ground are being restored, you run the risk of having counterproductive activities. You run the risk of creating interference and harming the customers. That is also one other aspect about an aerial platform, is that handsets now running on about 250 milliwatts of power. If you put an aerial platform that's very high up, you're going to have problems. Furthermore, you're going to drain that handset of power very quickly. Licensing and authorization. Obviously, we believe that any deployment should be highly coordinated with the licensees in the area and their restoration plans. There are a number of different ways that we can look at this, but some of the things that we think that should be considered is definitely that if a platform is going to be developed, it needs to have all the air interfaces in it from a commercial standpoint, and that there's enough separation, enough barrier bands in there so that they don't interfere. As you can imagine, if you put 4 or 5 cell sites up on the same platform in a very confined area, you're going to have some challenges. One of the things that we were able to do back, this is right after Katrina. Idaho National Labs looked into this pretty extensively and ran some simulations. Up on the chart right now is a graph that shows the window of opportunity for a DACA system. And as you can see, they laid this against the restoration data from Katrina and the timeline of Katrina recovery. And if you look at the graph, you'll see that obviously there's a large amount of commercial cell sites down in the beginning, and it's very difficult to see, but right in here, there's this narrow spike gray shaded area right there, that is this window of opportunity to deploy a DACA. And basically, as you can see, if you deploy a DACA, you're going to have high utilization on it for whatever capacity it has. But then you can see that rapidly the restoration starts to take over, and so then you get into the area that Dave had discussed, and that's where you're probably fighting against yourself, where you're actually, as you're bringing up cell sites, you're actually creating interference. The DACA is creating interference. So again, some of the ad hoc peer-to-peer radio access systems that could be used to maximize this issue, and we also think that if a plan is developed, then we can start to consider some of the standards or practices that may be considered. Thanks, Jim.
Clear the slides, please. Thank you. Good afternoon, or still good morning, I guess. Daniel Devasivalam. I'm very pleased to be here, and I thank you for this opportunity to talk to you all. So they said there'll always be some incidents that are too big for us, and we always try to make everything as rugged as we can. But the large incidents are so bad that however much we build our towers to however rugged they are, something does go down, and the fact of the matter is there is always an event that is too big for us. There's also the case where there is no coverage, like in a desert, in a wilderness area, for example, search and rescue, where there are cases where I think this kind of architecture comes in. And so the goal is to recover the communications after large incidents, but try to enable the existing terminals to work. The key concept is that we do the best possible situation for the most amount of people. The best possible for the most amount of people. So which is the best effort estimation. So the problem that comes up then is that you might expose some people to some interference. You might actually cause some people some problems for the greater good. Is this an acceptable situation? I think this is one of the questions that comes up. So clearly the idea is that you start off at the highest possible altitude, which will be satellites, but we are not going to talk about it in this talk. You come down lower, maybe to a high altitude platform, and then keep coming down lower and lower and lower to restrict your coverage and to restrict your power level, so that as things begin to restore, and also the whole question of capacity was brought up in order to keep up capacity, because the lower down you are, or the smaller you keep your footprint, the greater the amount of the reuse that you can use on the frequency. So this is of course a very fanciful picture. You really would do more like a figure eight, but the idea is that you are communicating with yourself. There is also the possibility of a balloon that comes up at a later point, but then you're also going to cause interference to somebody else. Well then, so the considerations on this are, if you were to say, suppose you were to decide that you're going to provide coverage at a quality of service, which in public safety is called a delivered audio quality of say 3, which is below normal public safety quality, and you want to stay as low as possible, you want to stay actually between 1,000 and 5,000 feet preferably, because at the higher up you go, the more the interference radius goes up. So the point that comes up is the higher up you go towards 50,000 feet, the greater the interference radius goes up, and it goes up a lot faster, because that your line of sight distance to the horizon goes up as the square root of the height, whereas path loss to your wanted cell, so the path loss goes up as height, whereas the path loss to the wanted cell goes up as height squared. So you actually start restricting the cell size as you go higher and higher, but you are beginning to illuminate a larger and larger area. Okay, so as you go up very low, on the other hand, now you start reducing your coverage too much, and now you find that you're not serving as many people as you can. So there's possibly an optimum location, an optimum height, an optimum power level at which you can operate. But as you get to see, so if you want to limit your interference, you want to stay low, you want to stay low on power, and then the question is, do you want to go analog or do you want to go digital? Well, with analog, you can probably get more terminals to talk to you, especially if you're talking about public safety. If If you talk about digital, now you have a whole bunch of incompatible systems out there, but digital does give you a higher margin. There's at least another 8 dB of margin that you could use with digital that will allow you to lower your power to serve the people whom you need to while reducing the interference. So this is the kind of trade-off that you need to worry about. So some of the issues. How do you define coverage? Now that seems like an odd question, but everything depends on how you define coverage. Because if you want to cover to a very high level of reliability, boy, you start overshooting and start killing other people. So that brings up the flip side. How do you define interference? Right now, there are all sorts of formal documents like TSB 88 and so on, where they talk about all sorts of calculations for computing interference. The problem with that is that those requirements are so tight, so stringent, that your interference power level has to be 20 dB or 15 dB below the noise floor of the receiver. Now that's fine for normal operations. They talk about the 50-10 contour, 50-50 contour, and so on. I won't go into the details. But remember, there's a disaster here. People are suffering. If you're on the adjacent state, are you going to be so uptight, say, I will not suffer any interference while you try to provide some service to those poor people out in Louisiana? Seems to me that there needs to be some compromise, and I'm sure the public safety community will be probably a little bit more sanguine about that and be willing to give some slack and some leeway for the benefit of the colleagues overseas, or in the next state over, for example, provided they don't get impacted seriously, which then brings up the other question. What is the impact? How much damage or how much interference are you willing to tolerate on your own system that is still up and running for the benefit of your brethren next door? And these are not just abstract questions, because all of these then result in kinds of numbers which can make or break this whole thing. Otherwise, this whole thing could be unworkable, just like Dave Buchanan said. So it has to be a case where there needs to be a dialogue with the community, I think. Then here's another question that will set some people on edge. The FCC databases are in many cases out of date. Why? People get licenses. At some point, they turn off the systems, but boy, they hang on to those licenses forever. So if you go back to your license database, you think that there are all these systems operating out there, and many of them are no longer operational. So relying on databases becomes a problem. So that becomes a question of sniffing on the air, and there's a long thing you can talk about cognitive radios and so on, about trying to do actual, like a roll call, but doing aerial sniffing to figure out what frequencies are available, what frequencies should have been there but are not there, which then begs the question, if my system is down, can I, for the benefit of everybody, loft my system? I'm licensed to operate at 300 feet. Can I take it out to 3,000 feet? Can I take it to 10,000 feet? What would be the protocol? How can I make sure that I don't clobber somebody whom I don't know exists, or who is willing to tolerate something for me, but I cannot talk to him because communications are down? So it's really not, it's partly an engineering problem. The engineering problem is very simple if the parameters are known, and to define the parameters becomes very much a regulatory and cultural and social problem. And here's another one. If yours is the only system that's operating with 2 towers in the middle of a large area, should you turn down or turn off your system so that a larger group of people can be covered using an aerial platform? Horror of horrors. Okay, so there are lots of interesting questions that come up. So let me summarize like this. There's a lot of work that's going on in this area. I myself chair the Software Defined Radio Forum's task group on deployable communications. Rather, it's called the hybrid architecture, which includes satellite and terrestrial and ground communications. There's work going on in Europe called the EULA program, which you should be familiar with, where they are looking at software-defined radios for doing sniffing, cognitive radios, for example, for trying to figure out how to do this. They're also trying to come up with a high-rate waveform for backhaul purposes and other purposes so that they can support a large user density in the ground. So EULA program is very important. If anyone of you is interested, please start following the conference calls on the Software Defined Radio Forum. Anyone who is interested, I'd be happy to talk to you, and that's being done under the WIN Forum. So I think the input from the public safety is important, input from the community is important, and finally, I think a whole bunch of people have to talk to each other, like the FAA and the FCC and the NTIA. Should you come up with predefined patterns of flight? Should this be already accounted for and planned ahead of time so that you know about these things, so that everybody's not just flying at random altitudes, because there are a whole bunch of other aircraft out there. So that would be the thing. There's a full-length paper on this, which I published in the Brussels Conference and Software Defined Radio Forum. Anyone who's interested, I'd be happy to send it to you. Thank you again for this opportunity. I think it's a very important area, and I look forward to being able to work with all of you. Thank you.
Yep.
Okay. Believe it or not, I'm a DoD person without any PowerPoint slides today. How do you like that idea? I want to expand some about what my colleague here was talking about, because I think our biggest challenge right now in trying to figure out how to do the DACA and come up with the architecture really lies more in the concept of operation. What is it we're trying to achieve by putting in these airborne layers? Because that drives the radius that you need, the altitude you need the platform to fly at, and lots of other issues. So one of the critical things that needs to happen near term is we need to figure out at what level are we supporting the state, the local guys, the first responders, the command and control of that local first responder headquarters to his guys out in the field, and then you start to layer back through the hierarchy, if you will, or up the chain from a DoD perspective, command and control, and you'll see that there are probably layers on the range around the orbit, if you will. There are layers that need to be supported and need to expand based on what level of command and control connectivity you're talking about, and the height and spectrum and all of those issues from a technical side of the house have to be adjusted to support that operational need for how much distance are you trying to cover and who are you trying to connect. There's been a lot of discussion this morning about cellular. I wholeheartedly agree that that is one of the critical things that needs to get restored quickly, not just the voice and the data side of it. However, as you do that restoration from an aerial platform, you suddenly cause an exponential increase in the number of people that can see that airborne cell, and we will run into the same kinds of problems that we did during Katrina, where a cell tower would come back online and within a couple of minutes be so overrun by the demand of the people that could see it, if you will, that the tower shut down again. The platform has to be flexible, to be configured before it's launched to support particular layers. What frequency what LMR frequencies are you trying to connect? What cellular do you need in that particular area? How do you restore the 911 and turn that back on? Do you put the platform up with the cell towers, several of them on a high platform, and run it just in the local area? Don't provide that backhaul off onto the national level networks. Just connect everybody in the local area so they can talk to each other. That's a huge issue during a disaster, is making sure that the folks out in the disaster area can talk to each other. Not everybody out there needs to call from Timbuktu back to Washington, D.C. Don't even put that capability up there. But there are groups of people that you need to be able to give priority access to the cellular coverage that do need the long-haul connections into the national network, and you have to be able to provide that on a priority, pre-planned, just like we do with the GETS in the priority access system today. That's got to be built into this system. There are just huge issues on the spectrum side of the house that have to be thought through, and I agree with my colleagues who have talked about the pre-planning. You've got to do that, and that has the platform that gets put together from a technical perspective has got to allow for remote management and the flexibility to change not just the antenna beams and patterns, but the spectrum, the frequencies, the modulation, all of that, so you can adjust on the fly based on what happens in that local area. Because there are lots of things happening on the ground that our databases don't reflect. People are going to change on the fly on the ground. You have to be able to match that flexibility on the platform if you're going to allow for it to continue to be useful in this disaster. On the cellular side of the house, there are systems out there today, and I won't get into naming, the manufacturers, but cellular technology has already reached the point where you can put systems out there that automatically sense the presence of other transmitters on a particular frequency, and they stop transmitting on that frequency. I would submit to you that any cellular platform we put in this airborne architecture has to have that capability, so you get a graceful restoration of the ground-based platforms without interference from the airborne, and it provides a huge increase in the availability frequencies for the airborne platform while the ground-based stuff is still out. That automatic handoff between the systems has got to happen, or you can't respond fast enough to manage the spectrum interference issues in the area any other way. I think those are the points that I wanted to make. I think this is a tremendously important effort for the domestic disaster response. DoD has been working in the airborne communications layer long since before I came into the department in 1979. We are continuing to work some of the same basic issues. The technology has changed, but when you start working about aerial platforms and aerial relays and connecting distributed locations from an airborne platform, it's basic physics. Those basic physics problems haven't changed. This technology is allowing us to do it much more smartly and quickly today. And for those of you who are here today to think about how do I build that platform, that's what my comments were pointed at, is to get you to think about the operational side of the house before you start bending metal and doing calculations for how to deal with the spectrum issues. Thanks.
Okay, good morning. I have both the blessing and the curse of being one of two more standing between everyone and lunch. So I'll try to keep my remarks fairly brief. And I do think that this is an important opportunity, and I thank the FCC for opening and hosting this workshop. I think it's clear from the prior panels and from my fellow panelists, with this emerging technology, there are some important implementation and coordination questions, some very key operational issues that we need to ask and answer. And hopefully the upcoming notice of inquiry will be an opportunity to build a robust record. I share many of the, I guess, questions and concerns from some of my fellow panelists, and I think there's some key themes. Speaking from the commercial carrier side or commercial mobile radio service bands of spectrum, I'll refer to them as CMRS. Wireless carriers certainly have every incentive to stand up their networks as quickly as possible. I think that you see their track record of deploying emergency response teams, their pre-positioning assets, and standing up networks as quickly as possible in response to natural and man-made disasters. And certainly we continue to do so. We talk about prior coordination, and I think that's an important issue to make sure everybody is cognizant of. I think it was on a prior panel, Mr. Steckler said that pre-positioning assets and pre-negotiating the contracts is essential. You can't negotiate in the chaos. And nothing could be more true than with wireless networks. And as you see in the wake of, let's take Hurricane Katrina, for example, you had thousands upon thousands of personnel setting up networks or storing networks. 427 cells on wheels or cows were brought in. 25,000 handsets distributed. This is in a matter of hours. At the same time, there are ad hoc waiver requests for waiver of rules. Power levels are increasing. Cell sites that remain operational are boosted. And you have home-in-home roaming or spectrum sharing arrangements. It is a very dynamic environment. It is a rapidly changing environment. So as we say, or as I say on a later slide, the notion of real-time coordination is also essential in addition to the prior coordination. So as I just mentioned, there are, in most instances, parts of the network that remain up and running, that remain operational. So we need to carefully consider how a deployment of a DACA system can occur without causing, as Jim mentioned earlier, perhaps more complexity, more complications to the disaster recovery efforts of wireless carriers. So assessing feasibility is key. So I think there have been there's a wide recognition of the interference potential. So we have to ask in the cellularized architecture, is there going to be that interference? Are there steps to take to avoid that interference or mitigate that interference, whether it's a question of trade-off or restoring communications for some for the greater good? Well, those are issues that I think need to be fully fleshed out, in an upcoming record in the notice of inquiry. So, and then there are questions about adequate capacity. I was glad to hear some of my colleagues on the panel touch on the notion of backhaul, and backhaul really is key. Are we going to go through these efforts, these steps, this careful coordination, only to have very limited capacity of the system that gets set up? Moreover, as was pointed out, you would immediately have numerous wireless handsets automatically seeing the DACA system. That could quickly overwhelm or jam that system, really rendering it ineffective for those who it's intended for. That's also another key question that should be fully fleshed out in this proceeding, is who are these DACA systems intended to benefit primarily? Is it first responders? Is it consumers potentially evacuating an area? Is it for, as the chairman mentioned, PLAN or the Commercial Mobile Alert Service to get essential information sent out to commercial carriers' wireless handsets so that they have the right information upon which to take action? So these are some key elements. Is it for commercial users to be able to reach 911? That's certainly been a priority of the wireless industry and the wireless carriers. They've been taking dramatic steps over the last several years to improve 911 service. The Commission, in the wake of Hurricane Irene and the East Coast earthquake that we saw, is properly asking some questions about how we maximize users' ability to connect to 911. And one key issue that I would hope is also explored in the upcoming inquiry is with backhaul, repeaters versus repeaters with backhaul capability. There is a difference in terms of consumers being able to reach 911, being able to reach the public safety answering point. So I would hope that we have a careful discussion and considered analysis of some of these solutions, depending on the goals desired. Let me just jump ahead. I seem to have a little bit of feedback. And certainly we, the industry, think we've responded fairly well to a number of incidents. Are there areas of improvement? Absolutely. I think there were tremendous lessons learned, and I commend the FCC for opening a proceeding in the wake of Hurricane Katrina think a number of steps have been taken based on what was learned in the analysis for restoring networks in the wake of that event. And I think you've seen improved responses, improved standing up of wireless networks since then. Just even with response in response to the wake of Hurricane Irene, there was some distorted information. So in the defense of the industry, what I'll say is it was pointed out that across the eastern seaboard there were 6,500 cell sites that went down, whereas Katrina knocked out 1,000 cell sites in a more concentrated area. The fact of the matter is, in the 200 counties that were most severely impacted by the storm, you still had 85% of the cell sites up and running, still operational despite heavy damages to commercial power and some of the wireline backhaul. So, the industry is taking steps. I think this is an important, as folks have pointed out, tool in the toolkit to explore. But in the commercial space and CMRS spectrum, there are some concerns. There are some issues that we would hope are more fully developed. Thank you.
Slides, please. Thank you. All right, so I am the last man, but I'm going to take my full 8 minutes. I got about an hour's worth of material here, and I'm just going to blast through it. Hopefully it'll be educational, enlightening, and entertaining. By way of background, COCO has been involved in deployable communications architectures that are IP-centric since 2002. Really, the 9/11 incident is the genesis of the work that has become the suite of COCO commercial products, which include both mobile mesh networking capability, which provides secure MANET networks, typically based on ad hoc Wi-Fi transmissions in places where there is not any infrastructure available. And also to extend that, voice interoperability products, which provide gateways, soft phones, and controlling head ends, so that push-to-talk users, public switch telephone network users, cellular users, and anybody on the IP net can participate in those push-to-talk conferences as well. A typical application of these technologies would be in a boarding team where handheld Windows devices are used by the members of the boarding party to penetrate a steel-hulled ship, where obviously the RF propagation is very much compromised. The technology allows them to stay in contact with each other as long as there is a clear air path through a mesh. Similarly, port security application where there might be some fixed sites, but also a lot of ships, boats, vehicles, or even man-portable devices that need to all be in the same communications mesh to enable operations in the dynamic environment. In addition to the commercial products that we provide, we've been engaged in some directed research efforts at the federal level, one of which is the USAF Aerial Networking Initiative known as GUNAS, the Global UAS Networking and Interoperability System. Interestingly, as much capability as the Air Force has in airborne and aerial communications, there is not one overarching system that binds together those capabilities into a coherent network that allows operation in an autonomous and mobile net with those disparate types of wireless systems, even the ones that are IP integrated. Clearly, any kind of mass market router products will not fully answer the requirements for this type of application. And we were asked to prototype a solution that would deliver self-forming nets based on existing Air Force link technologies and offer reduced congestion, improved performance, in a router package that's small, flexible, and easy to use. The environment in which this type of solution will play from a network perspective or the operational view here can be quite complex. This is a simplified version. You see some aerostats, you see manned platforms, you see unmanned platforms, including Global Observer, little tip of the hat there, as well as mesh networks operating within their own domains on the ground. So the number of moving pieces here and different technologies involved can be quite significant. The format of the solution today, and the Air Force is at our Seattle headquarters inspecting this prototype this week, is a commercial off-the-shelf computer, airworthy computer known as GoldenEye, loaded with COCO software, runs on the Linux platform, includes some radio to router interfaces which are customized to integrate the Air Force link technologies, and you can see the complexity of the software stack that comes into play here as well. But the key thing is it's a small, lightweight, low-power PC that essentially acts as a hub to bring all these disparate services together. The initial scope of something like a DACA architecture we wouldn't expect to be quite so ambitious. Certainly the Air Force has the luxury of more money, spectrum control, and time to engineer these solutions than folks in the public safety domain. But the kinds of problems that they encounter are going to be very similar to what public safety applications will encounter, especially as they grow to become more complex and cover more types of services. So I offer a list of requirements here that we developed in conjunction with our Air Force sponsor, things that can be improved, need to be improved in order to provide the capabilities that the warfighters need. I won't read the list, but things like latencies, network formation, healing times, non-disruptive topology changes with joins, leaves, splits, and merges, and multicast support are all things that become important. With respect to the COCO perspectives on some of the focus issues, largely what I have to say I think has been covered by previous presenters, which is good. All the technologies, all the individual point solutions have their strengths and weaknesses. The exposed node problem, the fact that anybody can see a airborne asset and that can become a bottleneck, has been well publicized here. And also the fact that typical end user devices are carried by what we call disadvantaged users, suffer from severe limitations on size, weight, and power many times. Interference to us is a generalized manifestation of signal-to-noise ratio problems. Generally, the thing that really separates wireless mobile applications from fixed applications are the fact that you get so much variation in these SNR issues. The one addition that I would make to the previous policy manual and autonomous mitigation strategies that have been mentioned are that we have found that often the application layer or some middleware between application layer and the network and RF technologies can be used to adapt to the fact that no matter how good your wireless network is, you'll eventually break it. You'll eventually hit a point where you're asking more from it than it's capable of delivering given the laws of physics. So consider making your applications resilient and anticipatory of that specific problem condition. In the multi-protocol world where we live, this word optimal is very dangerous. You can only optimize for certain things. You always have to take others somewhat off the table. And these are hard problems and require significant engineering and often custom approaches, including custom layering, to really provide performance and optimization. So things to be considered. The military is moving towards evolutionary models of these capabilities where on an ongoing basis they are tested, refined, and integrated. Ad hoc peer-to-peer mesh networking, where we do most of our work. Again, at the aerial, from an aerial perspective, very hard to do this without dedicated antennas, radios, and routers on the airborne platforms. That's something we've taken away from the military experience. And then finally, as has been mentioned by a couple of my colleagues here, Al and Bryant specifically, who had said, who are you serving and what service are you trying to provide? We would echo that, and I've called it the killer app. Figure out what your killer app is. What's the one thing that if you could do would make the most difference, the quickest, the cheapest? Focus on that, and then evolve capability from that standard once it's proven, once it's effective and accepted. Thank you.
Hey, thank you, everyone. Excellent presentations, and thanks for focusing in on those questions that I gave you. Jim, thanks for clarifying the one chart there. I actually went and read that paper, very good paper, including the one that Daniel pointed out. So a lot of good information out there. Let's go and see if there's any questions from the audience. Okay, you take the mic.
Hello, Ray Rothmel from Sprint Nextel. This is kind of more of just a thought. Maybe some of the panelists would want to comment on it, but I guess I was just thinking about in terms of 911. I think I heard everything from, maybe we shouldn't support it to it's very important to support it, but then, it might overwhelm the system. What would any of the panelists think about something like a 911 only type deployment, so that was the only calls that could be made and carried, and then perhaps also considering something like 911 and 311, which would be kind of a non-emergency use, but limited only to those two scenarios.
Thanks. Does anybody want to tackle that one?
I'll give a quick comment just from public safety side of it or background. There's probably some merit to that in that the cellular systems get overloaded, and it's because people are making calls, a wide range of calls, but when they're doing that, and when you maybe have also your landline POTS telephones down, it would be good just to be able to give people a direct access to the 911 centers so that you got the emergencies. I know now sometimes when the 911 system goes out, they'll deploy fire trucks out in neighborhoods, things like that, police that go around. You can't do that in a disaster, so there's probably some merit to that idea. I don't know technically, how you would do it, but
I think that there's merit to that idea, but again, as my colleagues on the panel have spoken, you got to understand what the intent and what the mission is. So you take a disaster where the threshold has been established or hit where an aerial deployment is applicable. It's a very, very wide scale area. That's my assumption. I mean, we're talking about hundreds of square miles. So those 911 calls go in. Where do they go? You assume you're using aerial because there's mass destruction throughout the entire area. So where do they go, and how far away are the responders? Then you also got the issue that if you create all 911 calls are not all calls are 911, everything becomes a 911 call. Is a 911 call obviously it's important, but also a voice call communications between a hospital administrator and an emergency manager trying to coordinate triage casualties is also important. So it all has to be looked at.
If I may.
Let's take Brian.
We can go in order.
Okay, go ahead, Dan.
I think this is one of those cases where there is no good answer. Because as was properly pointed out, if the only service is available is 911, everybody's going to make a 911 call at a time when everything is challenged. Now, with a back call, you might be able to route it to other 911 centers. But I know cases where, for example, I've been working in Kauai, and they have an emergency, and people in Oahu take the call, and they don't really know how to respond because they had not been trained with the emergency situation and the response centers and so on in Kauai, for example. That's a practical example I can give you. So I think there are many operational issues. ConOps is a very important area that we all talk about, But clearly, some restricted communications initially to first responders, but first responders without knowing where to respond is no use either. So clearly, we need to start expanding it. But key thing is capacity, and then gradually start bringing the services in, and still expect to have major congestion and probably a congressional inquiry or two afterwards to find out why things are so bad. So.
And you know, I agree with everything said, and Ray, I think it's a good question, a good concept. You know, I remember a year ago with the minor earthquake, I happened to be out at one of the Maryland PSAPs, and they said they were overwhelmed with calls of people calling 911 to say, what was that? So you do have, you know, the overload issue, and certainly if people understand that the only calls that can be made will be to 911, they'll be calling there for information. Your concept of 311 is a great one. I agree. It comes down to capacity. I think it comes down to capacity as we look ahead into a next-gen 911 environment. So if we're talking about messaging to 911, but MMS and potentially video, and you know, these could quickly overwhelm such a network with those types of applications running over it. And I think Jim makes a great point about you know, routing to which PSAP. Will such a network be able to provide location information and accurate location information? Is it going to be routed to the correct PSAP? So there are a lot of you know, details to be addressed in that, but good question.
That's great discussion. I think one more question over here.
Brian Stecker, Naval Postgraduate School, our earlier panel. It seems like most of the discussion today has been on the technical, the spectrum, and the operational. I have a question on the organizational and interagency aspect. I'd like to see what a couple of the panelists feel about the chances of interagency getting together and working together and pulling off something like this in a mega disaster a la Katrina or the big one in California or whatever, ahead of time, in time for that disaster. And if not able to do that adequately, then how they'll pull together and put that together after or during the response to a major disaster, because they need to.
Well, I think a couple things. That's a complex question. There's a lot of pre-planning that goes on all the time for public safety. We plan in California constantly, but if you term it in relationship to the aerial, it's a new platform we just have to work out, and I think that's what I was trying to stress. A lot of what I was saying is you've got to have some of this planning in advance, and you have to know that you can bring in, if you're trying to restore just your basic primary voice LMR, which is still the primary way that you manage incidences. All of that's got to be planned out, and we work together all the time. There's mutual aid in California that led the nation, I mean, when it came to wildland fires. So yeah, we're capable of doing it, but there has to be a regulatory framework before we can even start. You have to overcome that barrier. We have to know that we can get it. Cost is going to be an issue too. How do you fund the equipment, and where is it stored, and all that kind of stuff. So yeah, but it can be done, and we're good at it out in California, and frankly the rest of the nation is getting very good at it too.
I agree with David. Interagency coordination on this is going to be critical. Matter of fact, I see it as really the only way to do it. AT&T, we have 60,000 cell sites, and all of them are on the ground, attached to the ground. Let's put it that way. And we are aware of the work that's being done around the world with Daniel and others. We're very interested in it. However, as I said during my presentation, we believe that if the U.S. government believes this is an appropriate path to go, that it has to have all the CMRS carriers on it that serve that specific area, that wide area. That is the best way to do it. And so that coordination from the equipment to the power to the backhauls to the frequency coordination, just on the CMRS side, let's not even talk about the LMR yet, but it's just on the CMRS side, is a very big project that we're willing to obviously to participate in.
I may take a slightly different take on that, and that is the interagency coordination between various federal agencies, for example. What about the DoD? It is a 900-pound gorilla. They have SIGINT capabilities that we cannot even talk about. Could we fly one of these SIGINT assets over the country, over the affected area, to find out what's there, classify them, and to be able to send it out? I think we've been talking about this primarily in a civilian environment so far, but if in a really major situation, I think it's a national emergency, and there may be even regulations against flying those assets over our country. These are things that we need to think about and to see how we can leverage all the capabilities to be able to use them to, and then figure out where the information goes, the whole CONOPS issue, so that we can take action accordingly. But I think those are things to think about.
Let me also just add one other thing. I think that the understanding needs to be baseline that an aerial platform is not going to provide the same amount of capacity that a terrestrial-based antenna system is. That needs to be understood. I've obviously very concerned that people believe we can put an aerial platform up and instantaneously replaces everything on the ground. It doesn't even come close. It's a drop in the bucket.
Agreed. But as far as the interagency coordination goes, I mean, clearly FCC, FAA have got to get in sync for this to come together as a functional capability, and that doesn't even get at the issues of, is this going to be controlled and managed at the state level? Is it a DHS thing? Is it a combination of the DHS? What about the flights out over the coastal areas? Coast Guard comes into play. It's a very complex issue. I personally think it's something that really fits into the DHS's bucket of things to do. DoD, to answer your question, clearly has resources that can do those kinds of things, but it has to be appropriately tasked for us to be able to do it in a domestic event versus an overseas military event.
And I would just add, so I agree those are key points. I think, a number of the federal agencies have a good and strong track record of working together and also working with state and locals. Pre-planning, I'll echo what has been said and what I said earlier, is key, but I do want to underscore that, this is not just a moving target, this is a rapidly moving target once the restoration is underway. And the picture changes. We talk about situational awareness for first responders. There's situational awareness for standing up the network, and if that is not communicated and coordinated and addressed rapidly, we end up potentially causing more harm than good to standing up the networks.
Thanks. We have time for just one more question. Gentleman in the middle. Thanks.
John Coleman, XG Technology. First off, hats off to the FCC for bringing this body together, and the concept of the whole community. The three panels today well represented the whole community. We've got regulatory agencies, regulatory bodies, we've got individuals who represent public safety, we've got commercial industry, we've got academia, and we've got the DoD. Whatever solutions are embarked on, three criteria that I was trained in the military to look for in terms of a course of action being viable are suitability, feasibility, and acceptability. Suitability means it encompasses the intent. Back to your point about what is it we're trying to do with this. Feasibility means we have the wherewithal to put it in motion, and we don't create problems by the solution. Spectrum, has been pointed out today, is probably the thematic challenge to doing anything in the public safety domain and allowing the whole community to still take care of their own interests. Commercial entities that have grand capability for putting their networks back in motion, you don't want to stand in the way of that. You want to empower everybody to do what their core competency allows them to do and not bring that into conflict. And then finally, acceptability. Whatever we do has to be affordable. And in a day of declining resources in this country, it's probably one of the biggest drivers. I would argue that the proliferation of smart devices, and I'll challenge anybody in here that doesn't own one right now, and I challenge anybody in most disaster footprints who don't own one, whether it's a netbook, notebook, pad, or a smartphone. One of the ways to try and address the problem is to make sure we leverage keeping as many of these things operational as possible, or bring them online if they're otherwise non-operational. And again, back to the whole community, allowing those different representative sections that have those organic capabilities to do that is a good thing. The FCC's got, by the way, in the area of spectrum, some resource that lays fallow 85% of the time across the United States, 3 gigahertz and below. If you look in any one geolocation, you're going to find that 5% of the spectrum is in use in the busiest city in the United States, New York. It's 13.1% of the time. Now, the problem is that's always moving, so it all looks busy. But there is current technology that's being able to address what lays fallow. And we have unlicensed spectrum in the United States that doesn't run afoul of many of the spectrum issues, that if we could deliver carrier quality communications in unlicensed spectrum and deployed public safety networks in unlicensed spectrum, we could allow commercial enterprises to do what they do best, not interfere with them, and deploy a public safety network alongside it in a time of emergency. So I would just open the FCC to consider what you already have as a resource for utilization, and look at the technologies that might unleash that resource and use it in an effective manner.
Okay, thank you. If I could just pick up on that. So I appreciate your comments. Absolutely agree with you on suitability, feasibility, and acceptability. To the issue of unlicensed spectrum and kind of some other deployable situations that don't implicate some of the interference concerns. There are some even commercial carriers who have put forward some of those and suggested some of those types of solutions in the record. They've had some discussions. So those types of deployments are being studied and potentially being deployed. So that's out there. In terms of fallow spectrum, I think we're seeing the data tsunami and everybody, the smartphones, the tablets, as you've said, and in the wake of a disaster, we really see tremendous use, and it's even the networks when they're hitting without any damage, see some overloads to capacity, and that's something that we are working to manage. We do manage Wi-Fi, as well as I think it was brought up on one of the other panels earlier, heterogeneous networks, really taking advantage of variety of cell architectures and cell sizes, as well as different spectrum bands, all being deployed. The commercial side takes incredibly seriously our need to wring every ounce of spectral efficiency out of the spectrum that we have. What we find is in these disaster types of environments, we may not be operating at full capacity, and we're seeing tremendous traffic that we don't ordinarily see. So all challenges, but work that the industry is committed to working with our public safety partners and federal agency partners.
Thanks. I apologize. It seems like we could probably go on for quite a while and discuss a lot more questions, but we have to cut it off there. Panelists, thank you very much for all the time that you put in ahead of time. I know we had exchanged a lot of emails and a lot of preparation. So at this time, I'm going to turn it over to Jamie Barnett.
Pat, thank you, and panelists, thank you so much. I want to thank everybody who's participated today in our workshop on a deployable aerial communications architecture. Here on the East Coast, we experienced Hurricane Irene in September. There was damage to the communications infrastructure, some 6,500 towers. But as Brian Joseph indicated, that came back very quickly and bounced back. But during Hurricane Katrina, we didn't see that. It's not always the case that you can bounce back quickly when there's such significant damage. Hurricane winds in that particular case, compounded by flooding, the breached levees and damage to the communications infrastructure. It really was catastrophic. Single points of failure in valuable communication links and the long duration of power outages led to widespread communications outages. The Department of Energy reported outages to 2.5 million customers in Alabama, Louisiana, and Mississippi at that time. And then across the Gulf Coast, telephone switching centers and cell towers were seriously damaged. Almost 3 million customer phone lines were knocked out. Telephone service, police, fire, dispatch centers, and emergency radio systems were incapacitated. Most radio and television stations were knocked off the air for at least some time. In the heavily impacted areas of Hurricane Katrina, those outages were not repaired so quickly. And so really, as a country, I think we have to prepare for those catastrophic failures. And as addressed in today's workshop, this is the type of situation where a DACA could be very useful in restoring critical communications critically and quickly. So the ideas that have been put forth today by each of the three panels, as well as the concerns, were helpful. And in some cases, you've had great ideas. In some cases, like Brian's, you indicated what the questions should be that we should be asking. So on behalf of the FCC and the Bureau, I'd like to thank our guest speaker, Glenn Cannon. I'd like to thank each of our panelists and moderators. Thank you for sharing your views and expertise in this situation. And kind of trying to bring forward, I definitely heard some things that I had not heard before, and raising the technical issues that we need to address in going forward. So to our moderators, Rich Lee, to Jennifer Manor and Pat Amadeo, thank you, and some thanks to some of the folks that you saw that make this possible. So Chantel and DeAndrea and Jason, to Joanne and Kim, to Anthony, who helped us out as well, to Jeff and Steve, who handle all the media and make it possible for it to go on the web. So thank you for all the hard work that's been done to prepare for the workshop. And for each of you, continue to have this dialogue with us. This is information I think we need to move forward. And as you move forward today, have a very happy Halloween. Thank you.